السلام الملكي.
أعوذ بالله من الشيطان الرجيم. ولئن سألتهم من خلق السماوات والأرض ليقولن خلقهن العزيز العليم الذي جعل لكم الأرض مهدا وجعل لكم فيها سبلا لعلكم تهتدون والذي نزل من السماء ماء بقدر فأنشرنا به بلدة ميتا كذلك تخرجون والذي خلق الأزواج كلها وجعل لكم من الفلك والأنعام ما تركبون لتستووا على ظهوره ثم تذكروا نعمة ربكم إذا استويتم عليه وتقولوا سبحان الذي سخر لنا هذا وما كنا له مقرنين وإنا إلى ربنا لمنقلبون.
بسم الله الرحمن الرحيم. صاحب السمو الملكي الأمير سعود بن بندر بن عبد العزيز آل سعود نائب أمير المنطقة الشرقية، أصحاب المعالي والسعادة، السيدات والسادة الكرام، السلام عليكم ورحمة الله وبركاته. طاب صباحكم بالخير نحو بنية تحتية آمنة ومستدامة، شعار رفعت معه راية التحسين وسخرت لأجله أدوات التمكين، فبين التقاء العقول وابتكار الحلول نجد الطريق نحو تحقيق طرق مستدامة لمستقبل أكثر إشراقا. صاحب السمو، السيدات والسادة الكرام، نفخر اليوم بحضوركم يا صاحب السمو بقدر فخرنا بأننا المركز الرابع عالميا عن جودة الطرق على مستوى دول مجموعة العشرين، وبأننا نمتلك المختبر المركزي الأوحد من نوعه في الشرق الأوسط، كما ترتبط المملكة اليوم بشبكة طرق عالية الجودة مع 8 دول مجاورة، ما يعزز الترابط الإقليمي والدولي، وهي بذلك يا صاحب السمو تفخر أن تحتل المرتبة الأولى عالميا في مؤشر ترابط الطرق، ومؤكدة التزامها بأعلى معايير التخطيط والتنفيذ لضمان بنية تحتية مستدامة تلبي احتياجات الحاضر والمستقبل. أهلا ومرحبا بكم يا صاحب السمو مجددا في ملتقى صيانة الطرق. نلتقي هنا لنتبادل الخبرات وأفضل الممارسات بين المختصين والمسؤولين. نلتقي هنا اليوم لنستعرض التحديات والفرص المتعلقة بصيانة الطرق في المنطقة الشرقية، ونلتقي هنا اليوم لنستعرض أحدث التقنيات والابتكارات في مجال صيانة الطرق لتحسين جودة البنية التحتية وضمان سلامة وراحة المواطن والمقيم والزائر. نناقش ونتحدث ونستعرض لأننا اليوم نبني طرق الغد ونوسع الآفاق نحو بنية تحتية آمنة ومستدامة. صاحب السمو، السيدات والسادة الأعزاء، الكلمة الآن لمعالي رئيس جمعية هندسة الطرق والنقل الخليجية المهندس فهد بن محمد الجبير.
بسم الله الرحمن الرحيم، والصلاة والسلام على أشرف المرسلين سيدنا محمد عليه أفضل الصلاة والتسليم. صاحب السمو الملكي الأمير سعود بن بندر بن عبد العزيز نائب أمير المنطقة الشرقية حفظه الله، أصحاب المعالي والسعادة، الحضور الكريم، يسرني أن أرحب بكم في هذا الجمع المميز في ملتقى صيانة الطرق في دورته الثالثة، الذي يجمع نخبة من الخبراء والمختصين وصناع القرار في مجال البنية التحتية وهندسة الطرق، تحت رعاية كريمة من صاحب السمو الملكي الأمير سعود بن نايف بن عبد العزيز آل سعود أمير المنطقة الشرقية حفظه الله، حيث يأتي هذا الملتقى كاستجابة ملحة للتطورات السريعة التي تشهدها منطقتنا، والحاجة إلى رفع كفاءة واستدامة شبكات الطرق بما يعكس تطلعاتنا التنموية. إخواني وأخواتي، تأتي صيانة الطرق كعنصر أساسي في الحفاظ على استدامة البنية التحتية، فهي لا تمثل فقط حماية الاستثمارات التي تم ضخها في إنشاء هذه الشبكات، بل تعد أداة مباشرة لتحسين كفاءة الحركة المرورية، وتعد أداة مباشرة لتحسين كفاءة الحركة المرورية وتقليل الحوادث وخفض التكاليف الاقتصادية على المدى الطويل. وفي هذا الملتقى نتطلع لاستعراض ومناقشة أحدث الحلول التقنية، مثل استخدام الذكاء الاصطناعي لتحليل البيانات وتقييم حالة الطرق، وتطبيق تقنيات الاستشعار عن بعد، وتطوير مواد صديقة للبيئة لإطالة العمر الافتراضي لشبكات الطرق، والتركيز على الحلول التي تعزز من كفاءة الصيانة وتقلل من تكاليفها طويلة المدى، مع الحفاظ على معايير السلامة والراحة لمستخدمي الطرق. صاحب السمو، الحضور الكريم، مما لا شك فيه أن صيانة الطرق تسهم مباشرة في تحسين السلامة المرورية، فالطرق ذات الجودة العالية والصيانة المستدامة تضمن تقليل الحوادث المرورية التي تكلف الاقتصاد الوطني مبالغ طائلة سنوياً وتؤثر على صحة ورفاهية الأفراد والمجتمع. فالسلامة المرورية ليست مجرد جانب تقني، بل هي قضية إنسانية تمس حياة كل فرد منا، ويأتي تحسين السلامة المرورية على رأس أولوياتنا من خلال تطوير بنية تحتية آمنة. وتماشيا مع رؤية المملكة 2030 يركز هذا الملتقى على تعزيز الاستدامة في جميع مراحل التخطيط والتنفيذ والصيانة، وإن تطوير البنية التحتية يساهم في جعل المنطقة مركزاً لوجستياً عالمياً، وصيانة الطرق هي حجر الزاوية لضمان استدامة شبكات الطرق بأساليب تراعي أعلى المعايير العالمية. وهذا الملتقى يوفر منصة فريدة لتبادل الخبرات والتجارب بين الدول الخليجية والعالم أجمع، مما يساعدنا على تبني أفضل الممارسات العالمية في مجال الصيانة. إن تطوير بنية تحتية قوية ومستدامة ليس فقط هدفاً تنموياً، ولكنه أولوية استراتيجية تسهم في دعم اقتصادنا ورفاهية مجتمعاتنا. وأود أن أتوجه بالشكر الجزيل لصاحب السمو الملكي الأمير سعود بن نايف بن عبد العزيز أمير المنطقة الشرقية حفظه الله على دعمه الدائم، ولكافة الجهات المنظمة والمتحدثين والحضور على مساهمتهم القيمة في إنجاح هذا الملتقى. أكرر الشكر الجزيل لسموكم الكريم على حضوركم وتشريفكم. نسأل الله أن يوفقنا جميعا لتحقيق الأهداف التي نسعى إليها. والسلام عليكم ورحمة الله وبركاته.
صاحب السمو، السادة والسيدات الكرام، طرقنا تحكي قصة الريادة والتخطيط، وحول طرق المملكة نتابع وإياكم هذا العرض المرئي.
في قلب الشرق الأوسط ومنذ العصور القديمة شكلت المملكة العربية السعودية محوراً حيوياً على طريق التجارة العالمية، حباها الله بموقع استراتيجي يربط بين الشرق والغرب عبر قوافل تتحدى الصعاب. في تلك الأوقات كان الماضي بسيطاً مليئاً بالتحديات. كانت الطرق بداية رحلة المملكة نحو الوحدة، نحو النمو، ونحو المستقبل. واليوم نعيش تجربة تفوق التطلعات، صاغتها رؤيتنا الطموحة وجهودنا المتواصلة، حيث أصبحت هذه الطرق شرايين المملكة النابضة بالحياة، تربط بين مدننا وقرانا، بين حاضرنا ومستقبلنا. فقد تطورت شبكة الطرق لتلعب دورا محوريا في دعم النقل والخدمات اللوجستية وتمكين هذا القطاع، بما ينعكس على عجلة التنمية الاقتصادية مع ضمان الكفاءة والجودة وفق أفضل المواصفات الفنية وأعلى معايير السلامة. فمن جبالنا الشامخة إلى صحارينا الواسعة تواجه طرقنا تحديات فريدة تتطلب حلولا مبتكرة وبنية تحتية مستدامة تسهم في تعزيز جودة الحياة للفرد والمجتمع، وتجعل منها طرقا ليست فقط للتنقل بل لبناء مستقبل مزدهر. كان لهذا التطور ركائزه الأساسية لضمان نجاح المنظومة واستدامتها، وهي التكنولوجيا والابتكار ومعايير السلامة إلى جانب خطط الصيانة الدورية. الحاضر مليء بالتحديات، لكن المستقبل يفتح آفاقا جديدة للتطور والنمو. اليوم نحن نبني طرق الغد، طرقا مستدامة لمستقبل أكثر إشراقا.
صاحب السمو، نستأذنكم الآن برفقة معالي رئيس الجمعية بتكريم رعاة الملتقى. أولاً الشريك الاستراتيجي شركة أرامكو السعودية. الراعي الذهبي شركة شبه الجزيرة. الراعي الذهبي شركة أنساب. الراعي الفضي شركة رياض المملكة. صاحب السمو يطيب الآن لجمعية هندسة الطرق والنقل الخليجية وأمانة المنطقة أن يقدموا لسموكم الكريم درعا تذكاريا نيابة عن أمير المنطقة حفظه الله لرعايتكم الكريمة وعنايتكم الدائمة بأعمال الجمعية والأمانة. شكرا لكم صاحب السمو على كريم رعايتكم وتشريفكم، والسلام عليكم ورحمة الله وبركاته.
محاضرتين. صح. أي 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 التكريم أول. أي ببدأ أول شيء البريف السريع، الانترودكشن السريع، بعدين التكريم. أوكي. هنا كان يتكلم. عفوا. بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. أهلا وسهلا بكم في ملتقى صيانة الطرق، المنصة التفاعلية التي تجمع صناع القرار والخبراء والمهنيين لمناقشة سبل تطوير وتحسين منظومات الطرق وفقا لأعلى المعايير العالمية. يشرفني أن أكون معكم على مدار يومين من النقاش والتبادل المعرفي. نبدأ البرنامج بتكريم المتحدثين والخبراء، وأود أن أدعو صاحب معالي رئيس جمعية هندسة الطرق والنقل الخليجية المهندس فهد بن محمد الجبير لتكريم المتحدثين. Engineer Simon Tetley. Welcome on stage, Engineer Simon. Dr. Ninjuan Lee. الدكتور إياد مسعد. المهندس العباس الحازمي. دكتور آلان رولاند. دكتور ماريو مانوسالفاس. الدكتور فواز الحربي. الدكتور أمين حمدي. الدكتور محمد المناع. الدكتور علي السهلي. الدكتور حسين منصور. شكراً لمعاليكم. أما الآن نبدأ مع أول المتحدثين لتسليط الضوء على تقنية التقييم الكامل للرصف ودورها في تحسين أداء شبكة الطرق، من تقديم المدير التنفيذي في هندسة الرصف لدى المجلس الأسترالي لأبحاث الطرق. Everyone, please welcome Engineer Simon Tetley on stage.
Thank you, everybody. Good morning. My name is Simon Tetley. As the slide shows, I'm a Director and Chief Technical Officer at ARP Systems, based in South Africa at the moment. And I'll be giving a presentation on full spectrum. Thank you. How do I get this to work? Oh, there we go. Sorry, I was a bit of a loss of what I was supposed to do just now. I'll be giving a presentation on full spectrum pavement evaluation and its role in optimizing network performance. When we talk about pavement evaluation technology, I'm talking in this instance in the data collection part of it, the technology used to actually get the nuts and bolts and the condition out in the field so that can be analyzed and processed into the pavement management systems. It's very high level. I think there's about 40 slides, so I'm not going to be spending an awful lot of time on any of them. That will be more for tomorrow. And I was going to say this at the end, but I'm going to say it now. If there's anybody who would like to see more of a certain thing that is in here, because it's covering quite a wide range, I would love to know that, because then today I can whittle this down for the workshop tomorrow, that workshop presents what people want to see and want to talk about. Because a lot of the stuff in here you will all know anyway. It's just a story of data collection from as it was and still is in some countries to where it's going and where I see it going down the line. Okay, the content is fairly straightforward. It's an introduction, past and present, manual road condition assessment. I think most of us, particularly the elder generation, are all about that. Newer generation are not really that much used to it, I don't think. I'm not sure about in the Middle East, in the Gulf, but I would imagine most of it's semi-automated over here. In South Africa, still a lot of road authorities do manual windscreen data collection, which is not ideal for obvious reasons. The present, semi-automated, which is the norm around the world, and present and future, which is what I call a full spectrum automated road condition evaluation, which you will see just now. And again, a lot of you will know all about that as well. And then present and future full spectrum road safety evaluation, because safety is something that as pavement engineers we overlook quite often, and these days we cannot overlook it, and we shouldn't overlook it, let's put it that way. And then there's also the full spectrum road condition evaluation, but automated. That's just something I've been working on, to automate visual inspections, to take people out of the equation, which is a good thing. And then just some summary and conclusions right at the end. Okay, so just a quick brief introduction, and again, I'm not sure of the situation here. But typically, road authorities never have enough money to do what they need to do. It's just a fact. And therefore, what they do needs to be achieved at the lowest cost and the highest benefit. It stands to reason. Lowest cost lasts the longest. You can do more maintenance for your dollar or your rand or your real or whatever currency you're using, but that's the bottom line. But there's no point building cheap stuff, because that will fail. Current semi-automated road network practices are more efficient than previous. They are, but not necessarily more accurate. That's still subjective. Do I need it? No, I won't move around. No, I'll stay here. Thank you. So the bottom line is we need collection and analysis of accurate pavement data. There's no point picking up stuff that is not accurate. You're wasting your time. And it's essential that optimized maintenance and rehabilitation strategies can be identified, produced, and implemented. It's the bottom line. It's, I was talking to a gentleman earlier, it's like doing a pavement design. If your traffic is wrong, don't bother carrying on. To my mind, if your road pavement data that you collected in the field is not accurate, is not correct, you're wasting your time going any further than that. You may as well go back to the field and do it again. And we need to be basing it on fact and not opinion. Basing the condition of a road on fact, this is what it is, rather than somebody's opinion because Simon says that's a severe crack. That isn't the point. Okay, just very quickly, we can look at this again tomorrow. I'm not going to spend really too much time on this, but what this is trying to show is what happens when you've got a budget deficit. Again, I'm not sure here. In South Africa, that's typically the case. And this is just trying to show what happens if you've got a 10% backlog already after year one. That increases exponentially. Your green line is your budget allocation. Your purple line is annual maintenance need. The blue line is now your backlog, and you can see very quickly your backlog exceeds your budget. But year 7, year 8, within this model, with the numbers that I've used in here, but that's typically the pattern of what will happen. It might be slower, it might be quicker. But at that point, you're now in a problem because you can't do your backlog and you can't do your maintenance. You then end up with the red line, which is the normal plus the backlog, and then you're going to end up with the cost of that thing, which is the area under that curve. So not a situation you want to be in because it comes to a point where you can't get away from it unless you start throwing an awful lot of money at it. And then you can see on that side, that is what you need to do to bring that back. So again, financial planning is the key as well. Get that right in the beginning and your condition data correct from the field, and you've got half the battle won. Then it's just playing with numbers, and it's just doing the nice things. As it shows there, 200% increase in maintenance cost over 20 years. It's an awful lot of money. So just keep away from that situation. Past and present, this is how it was and is done still in South Africa. The sheet on the left is the standard visual assessment form. I don't know how many people have ever seen that or how many authorities have something similar to that. An awful lot of distress items. It works on a degree and extent rating of 1 to 5, 5 being very severe, and an extent 5 being everywhere, 1 being the opposite. Awful lot of stuff in there to go into the road management system. Windscreen survey. It needs skilled people. It's very subjective. Even with skilled people, if you have 10 people doing that, you're going to get 10 different answers, even if they're all skilled and qualified to do this. There's just some typical RAMS systems interfaces over there. That is the one that I did. I haven't used it for years, but it did actually work. And a RAMS is essential even for a small road network. You cannot do this on Excel, I don't believe. So you need some sort of system to actually get this thing working properly. I think I'm going to have to speed up a little bit. The present semi-automated road condition assessment. We've all seen the NSVs. That's got some crack detection on the back, so it's one of the newer ones. The unpaved data surveillance vehicle, just testing riding quality, and also cameras for condition, and then the FWD that we all know. So that on the left, it is the left, NSV, and the FWD typically go in unison on a network level survey just to pick up some structural data with the FWD. Though to my mind, it's often so widely spaced, it's just dotting an I and crossing a T. It's actually pointless, really, to give you any meaningful information to have one FWD test every kilometer. I wouldn't even bother. But it's dangerous as well. It really is. I've got colleagues who have been killed doing FWD testing particularly. So not ideal. We've all seen this, we all know this, I'm fairly sure, the post-rating of visual assessments. People sitting in the office doing what I used to do through the car windscreen. a lot more comfortable in there. You've got air conditioning, you can re-look at things. So it is less subjective and it is more accurate, I think, but still it's based on opinion. It's based on that lady there and that gentleman there, on his opinion. And so, yeah, we got human factor in there. Present and future. This is a vehicle that I'm sure a lot of people do know, but maybe some do not. This, in essence, though it doesn't look like it, is that vehicle on the left, the Mercedes, except it's a lot bigger, and it measures deflection as well. So it gives you a structural performance. It's also got a GPR strapped underneath it. So you've got eyes to look into the pavement as well. And this thing runs down the road at 80 kilometers an hour, in the US even quicker. And it picks up structural and functional data at the same time. And it's integrated and synchronized. So we've all done it, getting various discrete data sets and putting them on Excel and try to match them all together. You don't need to do that. This file comes out with everything to within 25 millimeters. So if it says that rut is by that deflection, you know it is. And those are just the lasers underneath, and then there's the GPR on the front there, and the beam for the riding quality and everything else, the automatic crack detection on the back. Present and future recognition of, okay, so that's just state-of-the-art structural NSV, basically the 11 vehicles globally, 11 of those iPaves, 300 to 500 kilometers a day. As I say, in the US they go a lot quicker, so they can get more than that on a good day, but they can get significantly lower than that. Same data collected as the NSV plus GPR and deflection. And it's based on fact. So this is what I'm trying to say. This is based on fact. It's based on measured numbers. It's not somebody's opinion looking out the window. And it's 100% objective and can be directly imported into HDM4 for that network analysis. And I think those are the numbers that I've got there. It's looking like it's close to 2 million kilometers globally that the iPave vehicles have done. And okay, this just is a very quick snapshot on the benefit of having structure and functional at the same time. Here we've got a structural and surface deficient. You can see by the chart on the bottom, the deflection on the bottom line, the negative value, and then the numbers on the top and the little dots and the lines. Those are all those various distress items. The red dots being the important ones to my mind, fatigue cracking. And then the black one is the IRI, which often goes together with the rutting, which it does in the middle, and it goes together with the deflection. Not always do these things talk to each other, as we all know. That's when we've got to start thinking about it, but in this instance it does. So what it shows is that you've got a predominant surface issues in the second half, which you can then cut down your remedial treatment. In the first half you're going to have to think about it, but the middle bit for sure, you're going to need something a lot more serious, some milling, some refilling, some strengthening going on there because there's something wrong, probably down in the bottom if I look at that deflection bowl. But yeah, that's just a fairly obvious one that you probably pick up with a visual. Here's one that you wouldn't pick up with a visual. The surface looks very good, and it is very good. The top positive axis, there's not an awful lot going wrong, but it's got very high deflection, and I suspect, I don't know where this is, it's somewhere in the US, I suspect this is a case of what I call wallpapering. The wall's full of cracks, you don't want to see them, you put some wallpaper on there, and it covers up the cracks for a while. And I suspect that's what's happened here, and it will not be too long looking at those deflections, particularly if that's a reasonably thin asphalt overlay, that's going to come right through there. And somebody's going to have to please explain, I'm pretty sure, or they should have to. Structurally adequate, but here's another one. It looks fine, structurally adequate. The deflection is very low, but we got some stuff going on the top there in terms of long cracks and various other bits and pieces. Not a lot of alligator cracking, so not a lot of fatigue happening there, which you wouldn't expect because the deflection is low. Rut depth also not terribly high, but there's some stuff to get done. So what it's saying there is you can go and treat that surface. And you've got confidence that there's nothing really wrong with the structure, so you can just address that. Whereas based on a visual, you're never too sure sometimes what is causing this, so you start digging test pits and doing all sorts of stuff. Here you can just use this. So again, going to a more fact-based assessment, just continuous versus sampled. We all know we typically sample pavements for pavement design, and it's a sample basis. It's not continuous. We're using it depending on the spacing you use the various things, but it's sampled. Yet a road doesn't fail on samples, and it doesn't fail on averages. It fails on the worst places. And yeah, that's just something I threw in there. Just some slides. This is what the guys see in the vehicles. This is what the guy in the office can see. I'm going to need to go through these a bit quicker, I think. Network project level. Again, this can be used for both, so therefore you do not have to do a network level assessment, then decide where you want to do your project level, and then you come back and get your project level team out. It can be used for both, and some road authorities are actually specifying this full spec. Economic benefit, full spectrum. I did with a colleague of mine, and there's a paper at IRF World Meeting a couple of years ago that shows that it is economically more beneficial in terms of cost benefit through HDM4 to use full spectrum wherever you can. It will be specific, yes, I mean you can't use the full spectrum on residential streets, but on your strategic main road network, it's the way to go, because every cent you can save doing this, that can be put into your road rehabilitation and your maintenance. FWD, TSD, is it comparable or not? That's a question I used to get 7, 8, 9 years ago. How does it compare to FWD? Just some very quick ones. I did a study, and again a paper that was published at SATC a few years ago, if anybody's interested, which goes into a lot of detail on this. It is very precise, but you can see on the right the bar charts. The blue and the orange is FWD. Ran 6 of those tests, and you can see even the FWD varies quite dramatically from each other, and it's the same machine, just slightly different times of the day. And then we brought in 2 machines in actual fact. And then the orange, or yellowy orange, that is now the results coming through from the TSDD, from the iPave, so from the lasers, from the calculated deflections, rather than the measured ones. And you can see based on the top is the D0 values, ranging from 156 to 160 and up at 170 on the top there, and then 21.2, which is in a poorer condition, as you can see from the deflection, is probably about 5 times. They're all running around about the same line, and in terms of bearing capacity, which, let's face it, that's what we want to know at the end of the day. We're not really worried about what shape is a deflection bowl, except to isolate where the distress might be, but the whole point of this is to tell me how many more axles can I carry on this road in the current condition. And we are running between 7.8 to 11 or 12 for the FWD, and between 8.2 and 9.9 for the iPave, so again comparable. And in terms of QSUM, uniform sections, it pretty much is identical. Those are the charts on the left through Horax benchmarking indices, and yeah, obviously where the line turns, uniform section finishes. And the blue and the red is the iPave and the FWD numbers, and then the lines are obviously the actual results, and then the 90th percentile value running through it, so you can see very, very, very close. So to my mind, yes, and I've been saying it for about 5, 6 years now, and I have used TSD for pavement design at project level, and I've never had any failures. Okay, it's just some benefits for, I don't know if I'm going to even bother going too much through this, but the main benefit to me is that you get continuous deflection with the iPave or the TSD. Every 25 millimeters, we can analyze and have done down to 100 mils on concrete roads to pick up load transfer at joints. At 5 meter spacing, you do 14 million deflection points. On this is on a network now, let's talk about. You'll do 14 million deflection points compared to 50,000 for the FWD at 200 meter spacings. It would take FWD nearly 300 years to do the same amount of testing at that 200 meters. And again, to my mind, it's the continual measurement which is the important thing, that FWD, even at project level, you're not going to be going quicker than or closer than 50 meters. And you know, if you assume that each data point covers 5 meters, you're pretty much covering a mere 10% of that project. So you're basing your pavement design on FWD deflections on only 10% of the area. Not really what you want to be doing when you're designing to a 90th percentile, typically on a major road. So, yeah. And then it just goes down to some costs and things over there, which I won't go into. People want to talk about this comparison more tomorrow. I'm more than happy to put some more slides in on this, or anything else for that matter. But again, the real benefit is replacing opinion with fact. That is the whole aim of this. Very quickly, present and future full spectrum safety evaluation. This is an iSave. It's got a sideways force coefficient, well, 2 wheels on it, so it measures skid resistance, but it also measures all the other stuff as well at the same time. So yeah, safer roads, better roads, safer roads. That's the mantra these days, and so it needs to be. So just like the other machine, except it doesn't do deflection, it does skid resistance. I won't go into any of this stuff. This is just depressing stuff. 1.2 million fatalities from road crashes, $2 trillion. That's what they cost. And I won't bother with any of this. This is IRAP, if anybody's familiar with that. That's a safety rating system. It's just trying to show that it improves on the bottom once the interventions have been done. Okay, fully automated road condition evaluation. This is some stuff that I've been doing or did a couple of years ago. These are typically images that come out of your automated crack detection. The different colors indicate the severity. The light blue is not too bad. And the orange and the red's obviously getting worse. This is based on width of crack and not the depth of it. And again, I was chatting earlier and I agree, the depth of the crack is important. To me, crack from bottom-up cracking is far worse than top-down cracking, typically. But I won't go again too much into this, but I try to do it through a simple numerical algorithm, as I call it. In other words, just a logic argument rather than AI. It's a lot quicker, a lot less time-consuming. I just wondered, could it be done? And we can look at some numbers just now. And to eradicate subjectivity. Use fact, not opinion. Again, and I'm harping on about this, but I can't think of anything more important. We engineers, we like using fact, yet we base a lot of the stuff we do on opinion over here, on this sort of work. So again, to ensure your PMS output is accurate, you've got to optimize all of this and your remedial interventions. This is again the TMH9 form that I showed you. Those are the distress items. The automation that we've achieved so far is in the green crosses, the green ticks, sorry. And the red crosses are the distress items we haven't been able to do using the numerical method. Pumping, for obvious reasons. Patching is the one that you have a problem with, typically. It picks up manhole covers as a patch. That's the normal one. And binder condition, you cannot really tell. Although you can from the color, I suppose, whether the binder is oxidized or not. But I think it's about 74%, yeah, 74% of all the TMH9 distress items can be identified. Just a very simple comparison with the automator on the bottom and the manual visual assessment on the left. 10 road segments, I think there were 500 meters each. 3 experienced visual assessors doing the manual. And then the iPave structural NSV doing the automated and using an XY scatter so just to allow that comparison. The red line at 45 degrees is obviously a perfect fit. And the blue lines is just a 5% error up and down to give 10% degree of freedom in there. And using coefficient of variation, not not R squared. And the red boxes, that is as per TMH9, the red box is very poor condition, so anything in there is going to be very poor, up to blue at the top, which is very good. And I tested for visual condition index and surface condition index and structural condition index and some individual distress mechanisms just to see if it does work. This is the visual condition index, and as you can see, the three assessors in the straight lines going up. It's not brilliant, but I think for a first attempt, it's not a million miles away. Even the visual assessors themselves, as you can see, are far away from each other. So coefficient of variation between 0.6 and 0.7, which is, it's not terrible, it's not great, but again, this was first sort of effort, this has to be fine-tuned. But in terms of production, manual assessment took a whole day. Automatic, it takes 1 and a bit hours. So again, in terms of production, a lot more efficient. In terms of VCI, the automated evaluation tended to rate worse condition than manual. In all cases, pretty much. And that's going to be a common thread through this validation testing. Surface condition index, which is the same thing as the visual condition index, but only relates to the surface, a lot bigger scatter, which I would expect, given the distress items they're looking at, maybe are not quite so obvious to the eye, whereas with the automated, it'll pick them up. And again, big variation between assessors themselves. It really is wide. And again, not such a good correlation, but they're all sort of, most of them are sitting up there in the green box. It's not the worst I've seen, but it's not ideal. But as I say, I was expecting that for the surface. The structure is, again, two assessors, it seems, were out a lot of the time. The red assessor, whoever that was pretty on the line. But again, it's not brilliant, but it's showing it isn't out of the question. So it's possible, in my opinion, and I actually go so far as to say this is not bad at all for a first go at what we were doing. And individual distress items, as the crocodile alligator cracking is called crocodile in South Africa. Alligator cracking, I'm not sure what it is here, maybe alligator, but fatigue cracking in other words. And as you can see, in almost all cases, the automatic evaluation is worse, as it was for the VCI, which is why the VCI is always worse. As per the index comparisons, acceptable results, I think. Rating of crocodile alligator cracking, 5 and 4, that is the degree. So the automatic rated a 5 and the manual rated a 4. So they're both rated, it's not good, it's very poor or poor. The one instance rate 4, the automatic rated a fair condition, and the manual was good. Which, yeah, there's something happening there. But apart from that, it's there and thereabouts. So I'm saying successfully automated there. This is now based on rating, and in this case, the automatic is based on a measurement. So it has to be right. I mean, that is a fact. And you can see that the manual rating is quite a bit different in places. A 5 to a 3 and a 5 to a 3 and a 4 to a 3. But a 5 to a 3, you know, if you're getting that wrong consistently on a network, it means that you're not rating the rating properly, and you're going to end up with a problem. You really are. So that's not a good thing. And again, it highlights the objectivity, or subjectivity, should I say, of using people, because they're trying to measure rat depth with their eyeballs. So the rating of rating house, it is successfully automated, because it is. And then potholes and failures, again, these are measured. They're measured and they're rated by the diameter, if it's a pothole, and by the depth for failures and potholes. In general, not a good correlation again. There's a 5 and a 2 that we can see there. And again, is based on fact for the automatic and opinion for the rater. So again, a cause for concern, if it were me and my road authority and I was seeing those sort of difference, I would have an issue with this, because those are serious distress items that they're not getting right. It's not like it's surface cracking that you can get away with. So a cause for concern, and again, I think successfully automated. So we've done this on 74% of the TMH9, and it just needs a bit more work on this. to bring it to fruition. And just a summary, we compared it, 10 500-meter road sections through individual assessors. I pave 8 times quicker to undertake the field survey, reasonable correlation, I think. Comparison of automatic and manual showed some concerns. Underrating of potholes and rutting, as I say, 2 serious distress items that typically come with a very high weighting in a pavement management system. And if you get those wrong, you're going to have a wrong answer, there's no doubt about it. And in general, automatic measured poorer condition. I'm not saying worse, I'm not saying it's wrong, poorer, I'm saying a poorer condition. Thank you. And 74% of all TMH distress items have been automated, and these 3 have been proven successful. I've proven the other ones successful, that these are the ones that I wanted to show. And just some benefits. It can be done, significant safety, it's significantly safer. There's no people involved. Objectivity, accuracy, appropriate immediate interventions, more kilometers per maintenance dollar. It's repeatable, as we can see. It reduces skilled resources, and the bottom line is it's based on fact and not opinion. And the way forward, just to adjust those sensitive algorithms and evaluate the items that cannot be done right now, expansion to full field validations with expert panel inspections, fine-tune again, and incorporation of, I want to do, deflection measurements into this. I've often thought where I want to do it, how I want to do it, but yeah, put those in there. If we've got that stuff, then we use it. And expand that to rigid and semi-rigid, in other words, block paving, and to composite pavements. And then finalization of algorithms and producing of working models. I reckon we're probably about 6 months away from that. And then just some very quick summary and conclusions. Maintaining requisite road network standards must be achieved with lowest cost, highest benefit. Current semi-automated practices are efficient, but still subjective. Budgets are typically always inefficient to address needs, and collection of analysis of accurate data is critical. And evaluation methods typically not progressed in passive technology. They haven't. Technology has gone far, but the way we do it, we still seem to sit with the methods that we know and we've always done. And as engineers, we should be doing new things, not sitting with old stuff, but I'm guilty of it myself. It's what you're comfortable with. Full spectrum automated technology is now widely available for over 10 years, in fact. That's been available. And the integrating functional and structural condition is becoming more and more acknowledged as state of the art. That is the way to do things. And it's just going to become more and more the state of the art and what people are going to want. And some road authorities, I won't name them, in some countries are actually specifying full spectrum condition assessments now. And yeah, the results compared favorably with FWD. And here we go. Road safety is important as road condition, which it is. Automation, yeah, okay. Full spectrum automation and road condition evaluation methodology. High accuracy, low cost, more cost benefit. And that's essential for what we want to do, which is optimize road network management. And again, I'm harping on it, road evaluation based on fact and not opinion. Thank you. Sorry to bore you. Could I turn it off? Oh, there we go. Thank you.
Thank you, Engineer Simon, for the fulfilled session to enhance the efficiency of road networks. أود التذكير لاستخدام الباركود الموجود أمامكم في حال وجود أي أسئلة تودون طرحها على المتحدثين في الجلسة الحوارية، ولتقييم تجربة الملتقى، ولتسجيل معلوماتكم الشخصية للحصول على شهادات الحضور. وأود التنويه أيضاً على تواجد أجهزة الترجمة الفورية أمامكم في حال الحاجة لها. أما الآن دعونا ننتقل إلى الموضوع التالي تحت عنوان التنفيذ الفعال لبرنامج صيانة شبكة الطرق المتكاملة مع التقييم الديناميكي لحالات الرصف. سيتحدث بها أستاذ ومهندس باحث في قسم الهندسة المدنية والبيئية في جامعة واترلو كندا. Please everyone welcome Dr. Ninjuan Lee.
you. How to use this one? Just keep it going.
Yes, you just,
This one, right?
Yeah.
Okay. Thank you. Okay. Good morning, everyone. It's a great honor and a pleasure to be here and meeting and discussion with you about road maintenance. You put the first slide here. Okay. My experience in terms of knowledge and practice in road maintenance comes from two aspects. One from the academic research area, as well as I do the research project and do the education for the graduate students from University of Waterloo and McMaster University and Toronto Metropolitan University, civil engineer. All of the three departments involved in heavily about infrastructure management. On the other part, my practical experience coming from my recent involvement of the construction companies, industry organizations, including Zhuoyang, which produce the data collection, which produce designing, manufacture, distribution, and application of road data collection equipment. Previous speaker talked about the FWD. That's one of the functions that we're going to have in the data collection. And the second one is JP Road Tech. That's the one I will use the example. Talk about the halting in place recycling asphalt pavement. I would assume you would be interested in that one because most of the roads are asphalt pavements. And this one talk about halting in place recycling asphalt pavements. The other one is talk about heater design equipment, infrared technology company. Talk about the heating, because when we do the recycling, and the heating is top one problems, and that's technology called heating, infrared heating. The last one called the Zhongling Group. Again, this is use a different heating technology, use the microwave to heating the asphalt pavement before you doing the either plant recycling or the hot in place recycling. Okay. Can you hear me back? Okay. Oh, this one. Which one to go? It doesn't go. It's from here, right? At the arrow. Oh, move this part. Yeah, thank you. Okay. And this is the other line I'm going to talk about here. There are 4 parts. Part 1. And as part of the transport asset management, the transport including roads, bridges, airports, seaports, and many other infrastructure asset management. So then today we will only focus on the road maintenance. Okay, that's the reason. I'm going to use the few flow charts taken from the existing practices for you to understanding the process of developing and implement road maintenance. Okay, and the whole idea is by showing this to leading you to attention the road maintenance. Okay, and for the road maintenance, I'm going to talk about two areas because 30 minutes is very long. Okay, and 2 areas. One is the impact of pavement data collection and the evaluation on road maintenance. Okay. Second part, we talk about the This is similar to the relationship between patients and the medical doctors. When the patients come to the medical doctors, doctor has to use various devices or assistant to do the testing, the measure, and to diagnose any problems you have. And based on that, as the evaluation, they will make decision what kind of treatment you needed. This is pretty much similar when it comes to the roads. The part C is we are very practical because we need to have this kind of forum, workshop, to discussion which one is better in the world and which one should be adopted to this province, the East province, to do better maintenance. That's my idea to how I should present to the people here. Okay, and to increase your impression of the maintenance, I have an example. It's called GP6000, the technology which used for holding-in-place recycling. Now I know where to go. Oh. Oh. Okay. I'm sorry. So somebody help me, maybe. I don't know. Which? No, you press this one here. Okay, not here. Okay, I see. Okay, good. Thank you very much. Okay. I lost 1 minute. Okay. The hierarchical relationship between transport infrastructure and the road pavements is showing here. Number 1, 2, 3. The whole idea is showing where the pavement is, where the pavement is located, where's the position. I mean, the infrastructure covers lots, right? The whole idea is, in the world, we talk about the infrastructure management, okay? Start from a big plan, the whole country, the whole national road network, the infrastructure plan, up and going level and levels, multi-layers, the hierarchy system, come to the roads. Even come to the roads, we don't have to look at the other pavement types. We only focus on the asphalt pavements because my initial idea thought probably here you will have majority of your roads as asphalt pavement instead of concrete pavement and other pavement. So you can see, okay, more practical, we're going to solve the problems with asphalt pavements. From this one, we do 2 things. One is how we diagnose the pavement condition and come up with the evaluation or assessment condition. And part 2 is how we deal, how we treat the exact pavement. Okay. No idea. And the philosophy is the same. Okay. Either is infrastructure or bridge management system or tunnel management system. The philosophy is the same. You're going to have I'm going to use the laser points. Okay. The laser points. The laser points. Laser. No. Okay. Okay, it doesn't have a laser. Okay. Doesn't have a laser. Okay, that's fine. Okay. So start from the objective. It's bridge or roads or seaports. Okay, you have the objective. You define the scope of your road network. Then you do the inspection or the monitoring. Then you have data. Based on the data, you do the analysis. The analysis the results from the analysis is the evaluation, is assessment, is a condition you know about this. Okay, and based on that one, you have to do the analysis. Then you come up with the repair or the treatment. Okay, similarly, and that's for the infrastructure. When we come down, hierarchically come down to the roads. Similarly, this is road network. Come to the road network. Similarly, you have defined the road network. This road network could be a national, could be provincial, could be city, could be a county. Okay, depends which organization you're working, which the network of roads that you are responsible. So, do the data collection. Okay, do the analysis, then come up with the maintenance. And today we're not talking about the prediction performance model. That's for the future maintenance. I'm going to focus on based on the data and collections, data collection and evaluation, what we should do now. And before we're doing that, the current evaluation data collection has some, I'll just disclose some problems. These problems, I call it impact on your selection of correct the treatment. Okay, and this one I can skip it because the previous slides, I think you already have a good idea what I'm going to talk about. This is the pavement management, and the two key things is the data collection, inspection, and identify the defects of the pavements. Second one, we pick up the treatments. Okay, so this is okay. Just watch my watch. I have to run very fast. The road condition is the evaluation is the process, and assess structural and performance condition. Okay, so that's very important for road segments. In terms of quality, the safety and the maintenance needs, okay, to meet the required standard. The implementation plan of road maintenance involves the local policies, regulations, engineering standards, and what and how all the pavement defects be identified, and we use in the road engineer we use the pavement evaluation indices showing here, a bunch of indices. You maybe already know about these ones, okay, and they showcase some of the practical application. Those are the data collection. I have been involved lots over the last 35 years, around 3,000, around 9,000 Zhuoyang, and total roads, this is a new one. And I want to point out some issues with and challenges and to the pavement evaluation. Okay, you may or may not realize there are some problems, and these problems are very serious. The evaluation pavement or data collection move on from a manual or visual evaluation up until now. You have use the laser, use the mechanical, use the AI to do analysis, use the image process, and even use the drone in the air, just like a helicopter, to do the data collection. Anyway, so that's something that's not my focus on today. Just you come to here is something that you may need to know. Once we come to the evaluation, we know the assessment. This is the assessment, look at the assessment. I took it from the website. I took it from the report. I took it from some studies, different. Some of the evaluation ranging from 0 to 10, some of the evaluation 1 to 5. Some of the evaluation, look at that one, corresponding to the real rating system. Okay, good, fair, poor condition. Some of 7, some of 5, some of 3. So that could lead you huge gap differences when you make a decision. Select the pavement evaluation. Okay, select the pavement the treatment. And this is good. This is good, like Bible. You know, use that one to keep. This is I think very good. from pavement, whether you use the manual evaluation or you use the semi-automatic or automatic evaluation, you still go through the process. Asphalt, for example, right now we have 19 asphalt in this case identified. Among the 19 asphalt, the distresses, we have four categories: structural problems, roughness problems, skid, safety, and surface conditions. Each of them could be, as I say, have an index, performance index, evaluation index. For example, structure, you use the structural index, use AA, roughness, use AI, and so on. Nowadays, we are using the decision trees replaced by AI. The AI, we are based on the data we collect to sign the weight and the decision trees, to convert the human beings, the experience and decision trees to the decision made by AI. Okay, that's what I'm doing now. Okay, and that's called a universal condition index. Okay, and I will tell you about that one because that's the one of the key things I want to mention. Okay, on this slide showing here, why is that so important? Because all of the evaluation, data collection, eventually come to the rating. The rating is linked to the decision trees. Okay, if the assessment rating, you make a mistake, you have a different categories. You cannot make a correct treatment or advisor to road managers, road engineers. Okay, and this is explain that one. Okay, I probably tomorrow have a workshop. We can talk more details, but just to give you an idea. The problems that everyone has a different. For example, this is typical, and you're supposed to go in the 100, and you have a different 7 levels. And sometimes I said, okay, I don't want to make a mistake. I just use these 3 levels. Then you won't make a big mistake. You just make a small mistake. All the mistake, you cannot see it. You use the 3 levels: good, fair, and poor conditions. Okay. Then you pick up the treatment. So that treatment, you will make a big mistake. But that's not cost effective. That's not efficient. That's not effective implementation. That's not what we wanted. Okay. Look at this one. This is again. Doesn't matter, it's manual evaluation, data collection, or the automatically data collection and the evaluation. Same thing, same result. Come to the same scenarios we are concerned. Okay, so that's the look at the same problems, right? Okay, part 3C. We talk about maintenance. That's the real things we are concerned. We really want to know more about that one. Oh, okay. The maintenance, we have preventive maintenance, corrective maintenance. And we talk more about the condition-based maintenance. There are many other maintenance, but I just talked today the timing, and I'm not good at control the timing, okay. The maintenance, preventive maintenance and the reactive maintenance, by showing these graphic or figures. Between these two, that's since we're going to make a decision what kind of preventive maintenance we're going to pick up. Okay, we're going to choose. Okay, from P to F, failure function, to P, the preventive maintenance, and between that, we're going to depend on the evaluation, depends on the policies, depends on your experience, environmental condition, traffic condition. We're going to assign different preventive maintenance treatment. Which one is the cost effective? We choose which one. Okay, so that's the one. Okay, and you have a very long list of treatment. But you have to pick up the treatments applicable to your region, to your province, to your country. And this is one of the treatment called hard impulse recycling. And you read it, okay, I'm going to skip this one, hard impulse recycling. That's the reason why you choose this one. That's the reason here. And usually they come to the between fair condition and good condition, come to the preventive maintenance and fair maintenance. Come to that point, you may consider the preventive maintenance. Again, the preventive maintenance have a long list, could be 8, 5, 6, 10, depends on which one you're going to choose in your decision tree. Okay, and one of the treatment called the holding in place recycling. This is holding in place recycling. Holding in place recycling, to be simple, it's just 4 stages. One is preheating the pavements. Here is very good. I know that temperature is very good in terms of to using the what's called hard in place recycling. Second step is the saccharification, to milling the pavement, then the mix and the pavement, then the compaction. That's to be simple, that's the fourth step. And what happens, I call the GP, I'm going to introduce the GP 6000. This technology came to university 5 years ago, and we signed an agreement. This is Dr. Tai, and he will be the university president, and he's a fellow of Engineering Academy, Canada, and specialized in pavement management, and also the hard in place recycling. We signed an agreement. We do the field lab work and the research, field work and research. Okay, we skip that one. And hard in place recycling meet all the requirements to be used in Canada and many other places. Okay, let's look at the 4 areas, because I don't have the point. Area 1, based on United Nations, there are some requirements. You read it. Based on the hard in place, the cost efficient, use the right corner over there. Okay, and you can see what's good for it. You can save energy, 35%. You can save the green gas, okay, 13%. You can save the resources, means 90%, because 90% of the aggregates will be reused. Then I look at this one. I come to the part 2, part 4. So this one, even when you bid in the project and you tender biddings, they show the company do the construction, you should make sure you meet this requirement. What is the requirement? We call the green roads specification, the adding scores. Those are the 4 categories. Each category you have a different requirement. They look at this one. Oh, you have this one. You can able to do this one. I give you a score. Okay. As long as your score got it 16%, 0.5%, you are good. You are ready to go for bidding the project. And this is kind of a policy directed bidding the project, working on the project. And GP 6000 has that capability of doing this kind of job. As I mentioned, they're doing the design, manufacture, the contracting, okay? And I visit last year the manufacturer to design, produce, and using this kind of the equipment. There are 5 key areas that we should mention here. At least I should finish this part for 5 key things. And one is preheaters. 3, the heater miller. Second one. Third one's windrow heater. And the last one's mix, adding the new asphalt and paving. Okay, let's go one by one. And those are the details we can talk tomorrow, right? Getting into to the workshop. Okay. Look at the picture here. The first 3 is train, right? The first 3 is heating. Okay, and okay, I have to speed up the 3 heater. And once you're heating, and the second one is the windrow heater. This is different from the previous. Why? Because it's observed, it's vacuum. The heating, the smoking come from the first heating to recycling into the system, then burning again to heating system. So no smoking anymore. The part 3, the mixed paver. The mixed paver has the function of adding the new asphalt, which is 25% or 20% whenever based on the analysis. The last one's paver, okay, compaction. So look at some details, okay, why you say that one, it's okay. the what's called the JP 6000. Okay, look at the number one here, igniting the fuel, the gas, right? All the gas to burning to get heater. The heater will be used to warm up, to heat the asphalt, going down to the number 3 heating, right? But in the meantime, do you see here? Because I don't have the points, I use my points here. Going to up, that means recycling, vacuum this air. But and then use the fan. The fan is pump the heater into the combustion again to burning the one has been used the first time, but not burned and used completely because some of the smoking and emission component particles has not been is toxic. It should be burned again. After that process is clean. So, and this again, that's the way. Good. You go in, burning, and then from there, because number 3, the fan. The fan take the unburned. They got the fuel again, going the second time or third time in order to get the fresh, the air condition, right? The environment condition, sorry, the environment condition, compared to the common one we used in the past. You can see it. And I did see that. I saw that because I went there, see it. The other thing is they warm up this one for 30 seconds to 40 seconds. After the melt, they warm up, they have a system to warm up to keep the temperature up to 140 degrees, which could be used for pavement, okay? And to do that, not only that, so it's not breaking down, crush the aggregates. It's because it's warm, right? So the 90% of the aggregates can be used again. So that's another good reason we use hot in place. Okay, this is showing the windshield. The windshield could keep this 30 seconds to 40 seconds. Then adding to the last step. This step, okay, they warm up 30 seconds and before the pavement. And then next one, the last step is adding the new asphalt. 20% because you want to have adding some new aggregates because you still have aggregates lost or find, and you need the aggregates anyway to 20%. So then they pave. Okay, so that's the basic idea. And in the meantime, they have a digital border. Okay. And this one, dashboard, to control temperature, working temperature, inside the mixture temperature, and the asphalt materials temperature, to make sure they can be operate at the same time in the required temperature. Okay, so that's the whole process and the philosophy and the application. Okay, this one. So it's kind of a conclusion. The emission substantially controlled because it's stuck, okay? And the vehicle can be passed safely, and the working condition much better. People working on this one, you don't have the poison or toxic materials as your working space, okay? And this one has been used over 1 million square meters during the 2023 and 2024. Many located these 4 provinces. East province, okay, actually the manufacturer located the East province, like the province we have here, we East provinces, and many other provinces, okay. Okay, that's I think this is all I want to say. Thank you very much. Good.
Thank you, Dr. Lee, for the inspiring session. Thank you, Dr. Lee, for showcasing the best practices in road maintenance. If you have any questions for Dr. Lee, please do not hesitate using the barcode that is in front of you to submit your questions or inquiries to discuss it during the panel discussion. أما الآن سنتوقف لاستراحة صلاة الظهر ونعود في تمام الساعة 12:30 لاستكمال البرنامج مع المتحدثين. شكرا لكم. أهلا بكم مجددا. نستكمل برنامجنا لهذا اليوم مع الدكتور إياد مسعد، بروفيسور في كلية العلوم والهندسة في جامعة حمد بن خليفة في الدوحة، متحدثا عن إعادة التأهيل واستراتيجيات المحافظة على الرصف الإسفلتي مع الأخذ بعين الاعتبار التغيير المناخي. أهلا وسهلا دكتور.
I'll take the mic and this is forward back. إن شاء الله. السلام عليكم ورحمة الله وبركاته. It's my great pleasure being with you today. I want to thank the organizers for the excellent arrangements and for, of course, the hospitality that's not foreign to the Kingdom of Saudi Arabia. It's my pleasure being with you today. I'll speak about a topic that is actually global concern, which is the effect of climate change on our infrastructure, including asphalt pavements, and what can be done for adaptation in order to cope with this expected climate change. Just to give you a warning, since I'm a professor, I'm an academician, there will be some focus on innovation and what can be done now and in the future. My outline of the talk, I will give a quick overview of what's driving our industry, especially on focus on pavements, what's driving in terms of overall thinking and overall strategies. And then I will show you data about the effect of climate change, and I will borrow the data from studies that were done, in fact, in Saudi Arabia, and studies that are done internationally. And I will make the point that climate change is not just a foreign idea, it's actually a true expectation of what's going to happen, and we'll then zoom in and talk about how does that affect our maintenance, how does it affect our thinking about roads, and how does it affect the performance of these asphalt pavements. And then I will give you some focus on adaptation methods. How do we adapt to this change that is coming in terms of material, design, rehabilitation? And then I will look into the future about what's called smart pavements. How do pavements become smart? And how do we get information from pavements rather than treat them as dead bodies, rather than a passive system? How do we treat them as an active system that feeds us data in order to make proper decisions? So that's my talk. Some quick data. Of course, we're talking about a very important asset, which is asphalt pavements. In the US, 4.3 million kilometers of paved roads. 94% are surfaced with asphalt. Europe has 5.2 million of these paved roads, 90% surfaced with asphalt. In the Kingdom of Saudi Arabia, I hope this number is accurate. I got it from different sources. Saudi Arabia has 230,000 kilometers of paved roads, 90% are surfaced. These are real assets, as you all know. That's why we have this forum. That's why the focus on maintenance, in order to sustain these pavements to the extent possible, because they are quite expensive. These are soft numbers from the US, rough numbers from the US. It costs $1 to $1.5 million per kilometer to have these roads in rural areas, up to $3 million in urban. So we're talking about a very serious asset for any nation, any country, any region. I had the privilege of visiting the Heritage Village here in Dammam last month in November, and I took this photo. It says an asphalt paved road by Aramco, which is considered the primary artery. I like the expression, الشريان الرئيسي, for the kingdom in 1957. So we, as a community, we are building arteries for our nation. We are maintaining these arteries for the nation. Okay, what are the main drivers for innovation in asphalt pavements? The first one, major focus on what's called pavement resilience. What does this mean, pavement resilience? It means that the pavement can take a disruption there, the curve, if you look at the curve up there, it can take a disruption. It will be disrupted, it will reduce in capacity, but it will not collapse. It should not collapse. And it will maintain some level of performance called the disrupted state, And then we need technologies that allow us to make these pavements recover rather quickly, self-heal, materials that does not collapse. Because, as I will make the point today, because of climate change, there will be more distresses, more events that may cause our pavements to be severely affected. So we want to build pavements that can take the hit, absorb it, and recover quickly. Not only recover, but adapt and become better. That's a concept of resilience pavements. It's a whole new concept because of the disruptions of floods. All of us know that we see more floods in our region. We see more precipitation. Extreme heat waves are increasing, as the data will show it. So the concept of pavement resilience is the design maintenance concepts. How do you design pavement that are resilient? Also, pavement sustainability. And the point I'm making here, what does pavement sustainability mean? It means that these pavements achieve specific engineering goals as designed. They meet basic human needs. They use resources effectively. My colleagues, Dr. Lee, spoke about hot in-place recycling. There is cold in-place recycling. All these recycling methods, you will see more and more of it. No economies can sustain, no environmental, because of the environmental effects, because of course, with the nations, the countries will not accept that we keep digging raw resources to build with. They want us to recycle things, not only once, not only twice. There are studies that shows we can recycle roads 3 times over so extend its life. But the concept I want to make here, it's not only about materials, but it's also about how do we design pavement and how do we design them such that they can be sustainable and they can stay. And it's a life cycle. In that, we need to be careful when we talk about sustainability. Most often, when we talk about sustainability, falsely we talk about one piece of this cycle. What does it mean? Recycling a material does not make the road sustainable in itself. We have to show that it's sustainable over the full life cycle cost. From beginning till end, we recycle this pavement. The pavement is sustainable because we can show by life cycle assessment that it costs less, environmental impact less, and it is more efficient. So we should not look at a piece of it. One piece of the cycle can be very misleading. There are technologies that show recycling of materials, but you can show that this material cannot be recycled again, which means it's not sustainable. Okay, let's talk about climate effects. What do we mean by climate effects? Extreme heat, precipitation, and flooding. And what's more enemies to pavements than these 3? We all know that we design pavements to sustain loads, heat, moisture. And I will show you data that shows what's going to happen to heat and moisture with time in the kingdom, in our region, and globally. And I'm going to rely on these 2 reports. One report is issued in Saudi Arabia by CAPSARC and by KAUST and a consultant, and one is a global. This report is an excellent report issued by KAUST showing data and studies about climate change in the kingdom and the region. Here is some data. And please, this data can be confusing, so I will point out what this data is telling us. Let's look at this curve. These curves are showing the light blue is what you expect global warming to happen. And the dark blue or greenish is what is expected to happen in our region. The message here that for all scenarios, there are multiple scenarios. These are environmental scenarios. Whether humanity is going to do something about the green gas emissions or not, there is a scenario. If we don't do anything, there is the worst scenario. If we do a lot, there is the first scenario. But the message here, no matter what we do, our region will be more impacted than global. Let's take a scenario. If the increase in temperature globally is 4.4 degrees C, the temperature in our region will be 5.8. That's serious for design of asphalt pavements. That's a serious increase. What makes it even more an issue, let's look at this. This is not the average increase. This is the extreme increase. What does it say? Let's look at the last scenario. The last scenario says if global warming is 4 degrees, the kingdom temperature will rise the extreme by 6 degrees. So if we are experiencing in the eastern province of Saudi Arabia, a temperature of 45, in years to come, it could reach 48, 49. What does that mean? For those who do pavement design and analysis, what does it mean for your asphalt pavement? Even more increase than that. So we have to pay attention that the pavements we design today, if they are sustainable, they have to sustain these increases in temperature in the future. Let's look at, this is the most revealing. It's not only the temperature goes up, is how often this extreme temperature happens goes up. Let me focus here on this graph here. This shows, let's look at this data. In the previous century, actually the century before, the event that used to happen once in 50 years, the extreme temperature rise that used to happen once in 50 years is expected to happen 39 times in the future. So it's not only the temperature is going up, but how often it happens, it's going up. The frequency of it is going up. Same story for precipitation. Again, this data is model data for the kingdom, that the precipitation is increasing. It's all red, green. Green means more precipitation. How more? It could be 30% more than what we used to experience. So it's no surprise that all of a sudden you hear people saying, I've never seen this rain before. I've never seen this event before. It's not only you haven't seen it, but you haven't seen how often it happens. It's going to happen, what used to happen once in 10 years, it's going to happen three times in 10 years. Okay. What does the pavement community say about that? There are reports that says, well, we have to take care of it. How do we take care of this? We need to increase the resistance to rotting because temperature will go up. Increase the PG grade. Increase the resistance, reduce moisture susceptibility of unbound. Increase the surface friction. But that's easy to say. The question, what innovation, what methods we need to include today in order to achieve these goals? These are excellent goals, but do we do about it? So there are adaptation strategies. How we choose our material is an adaptation. How do we design our pavements is adaptation. And we may have to change the philosophy of how we design our pavements in order to sustain these effects that's going to happen in the future. Maintenance and rehabilitation strategy. Those who are in charge of maintenance and rehabilitation, if you are budget amount of reals or dollars today, you may see that that budget may increase in the future because the frequency of your maintenance preservation will increase because of this increase of moisture and heat events. So what my colleague spoke about, the first speaker today, about automated detection of distresses becomes even more important because these distresses can start showing up more faster than what people expected them to happen because of these effects. And then I will talk about smart pavements and how do we make pavements speak to us. I'm not imagining. We want pavements actually to talk with us. Tell us how they are, what they are experiencing so we can take the actions. So this is some of the example of material adaptation. Plastic modified asphalt. We built this section in the port in Qatar with the Qatar Petrochemical Company. In fact, while I was sitting with you today, I got a very nice message on WhatsApp from my colleagues in Capco saying, the road is doing well, we inspected it today, it's been a year and a half. We built it on the most difficult spot. It's where all these containers come and load, and they are a curve. So I was honestly concerned when we built it. This is using 4% plastics, low density polyethylene, the low cheap material of plastic that would end up in landfill to modify the asphalt. That's not the end of the story. The story is, it's not only you are recycling plastic. Your asphalt, in this case, improved from resisting 64 degrees C to 76 degrees C. So we call it value-added product. You convert it from a landfill to actually valuable material, not only recycled material. You are not hiding it. You're actually saying, this is a valuable product. I can make my asphalt, instead of importing polymer from outside, I can recycle this plastic, and this is good for hot weather. If you are in a cold environment, if you are in a mountainous environment, I wouldn't recommend it, for example. Another example where we are using polymers environmentally friendly polymer to modify the soil. Why that is important? We're trying to find alternative to cement. Cement is a great material, but it's high carbon footprint material also. So we're trying to find alternative, and this is a study we are concluding now. I wanted you to look your attention at the square, and this is the soils that we tested and how with moisture it dived in, which means that the soil has collapsed. But when we use these polymers that we engineered and we chemically modified, we were able to make the product resilient. What does resilient mean? Of course it's gonna drop, but does not drop to a point where it collapses. It can sustain the load, and it can recover later due to healing. That's an adaptation that can be for materials. This is a study from my colleagues in the US in the design. So I talked about material adaptation. Let's see, what does this mean for design? The numbers mean how much thickness you need to increase the pavement in order to sustain future climate. What does this mean? I designed the pavement based on today's climate. I want it to last 30 years. If you want it to last these 30 years, because of the climate change, actually the thicknesses will increase, alarmingly increase. Depends on the scenario. Of course, this specific scenario, so I wouldn't take these numbers and say this is exactly what you will do. But it shows that the pavement thickness could increase 20%, 30%, 10% because of climate change. So real implication. This is a tool we developed with one of my PhD students who has a small consulting company. Those who are in pavement community know that the world is going to what's called mechanistic empirical pavement design. I call that a monster. And they say we need to make it work for our region. So we developed a tool that works for Qatar. Qatari climate, Qatar soil material, and we use that tool. It actually can run on an Excel file. So it's not a huge software. And what we did a study. We generated another tool that generates different temperature scenarios based on climatic data from Qatar. Can be climatic data from anywhere. We looked at what happens if the temperature increased by 1.5 to 2.5 degrees in 30 years. And what happens, not only if the temperature increases, if heat waves increase. That's different. One is increasing the average, the other one is increasing the peaks. So we want the peaks. So all of a sudden you said, this week is the hottest week of my life. That's what we are adding here. And what we show, that the increase in rotting is about 20%. The increase of total rotting, this is the AC rotting, is 10%, the total, bottom up. And this is misleading. It shows top-down cracking, there is no increase. I want to say, please, if you are designing mixes in Saudi Arabia, in Qatar, in Bahrain, in Kuwait, in Oman, United Arab Emirates, be aware that we cannot just add high stiff binders expecting the material will perform. In fact, we show that because of the type of mixes some of the regions are using, you end up with a lot of top-down cracking, longitudinal cracking. They are not bottom-up, they are not so expensive to fix, but they are problematic. And those mixes we are designing are not the best for this type of behavior. So we have to adjust our mix design methodology in order to prevent something from this happen. Historically, this region has suffered from rotting. Because of that, we took a reaction. And we start designing so against rotting. I'm afraid we are going too much into the other side of allowing top-down cracking. Okay, quickly on the maintenance and rehabilitation. What does this mean for climate change? Data has shown that you need, there are models for climate modeling to predict what is the effect of climate change in your maintenance strategy. And the recommendations say we need to invest more in sensors and monitoring system to track pavement health because of this acceleration in damage. But what's interesting is this data from China. It shows maintenance preservation cycle are triggered 8 to 16% earlier than what we are used to because of climate change. Another data, it shows very clearly that we using an LCA pavement framework to assess maintenance and rehabilitation alternatives with respect to climate change is needing for planning and budgeting decisions. Because you might be you need maybe to increase the frequency and the type of maintenance that we use. This is from a study, another study that shows, this is, I don't know if it's clear, the top one, if you use the maintenance cycles, if you use historical climate data, the bottom curve is the maintenance cycle if you use future climatic projections. What do you notice? The maintenance, in order to maintain the same performance, in order to achieve the same performance, climatic change will force us to do our maintenance more often. When I'm talking about maintenance here, I'm not talking about routine ones. I'm talking about, of course, routine are important. I'm talking about preservation strategies, network level maintenance, treatments, overlays. They will happen more frequently in the future. This is something just quickly, and here we need to differentiate between rehabilitation, which is restoration, resurfacing, recycling, and reconstruction. Dr. Lee talked about one of them, recycling. That's major rehabilitation. That's not what I'm talking about. Here we're talking about pavement preservation program. Take care of this asset through three things: minor rehabilitation, so you don't wait till things deteriorate in order to take care of it; preventive maintenance, most important; and routine maintenance. Why preventive maintenance is the most important? Because it's a planned strategy at the network level. It's things that are planned, it's at the full network level, and it's something you do to prevent things from deteriorating. In addition to minor rehabilitation, surface treatments, and routine maintenance. Here, there are some examples of these preservation strategies. Fog seal, slurry seals. By the way, it's annoying in my field that we like to use jargons. It's confusing. Even when I educate, when I talk with my students, these jargons sometimes are not necessary. Sometimes these are for marketing purposes, not really for performance basis. So we have to be careful about all these terms that keep coming up about preservation strategy, that they just mean changing in materials. But let's talk about fog seal. There is the just spray of emulsified asphalt. A slurry seal, you add some rock on it. And then chip seal, which is very popular for the place I worked for 20 years in Texas, where you spray asphalt and rock. And then microsurfacing, where you are using polymer modified emulsions. Any of these treatments, we were able to map it. This is a study was done with our colleagues in Kuwait, in Kisar, where we mapped those methods from literature, not us, from the literature, to say when do you use any of these treatments? For example, there are other treatments, but when do you use them? When they are efficient and when they are completely not needed. Okay? So we have to check. It depends on the distress you do. It depends on the type of distress and the cause of that stress. You decide on the rehabilitation strategy. For example, if I have alligator cracking already, none of these methods work. Even marginal is a stretch. But if I have moisture damage initially at the surface, yes, they do work. So we have to map and I ask the question. This is from US data. What does it mean for our region? Because of hot temperature, do these treatments work? So we need trial sections. We need to do work on the field, not in my lab, in order to decide what does this map look like for our region. It might be different, this mapping. Maybe close, but not exactly accurate maybe for our region. Okay, my favorite topic, smart pavements. I say we need to make pavements smart. There is a lot of effort globally in saying that pavements will no longer be only rigid systems. They will be the house of generating energy. They will have sensors in order to tell us about these stresses. Now it's not strange that we can collect data from the pavements, and AI will process it and tell us this pavement started to deteriorate, not only by scanning the surface, but only embedding sensors that immediately, continuously giving us data. Is this a stretch or imagination? Absolutely not. There are a lot of industries who adopted what's called digital twin. Let me tell you what digital twin is. Digital twin, you create a digital copy of your asset in the computer. And you start training this digital asset in the computer from the real data you collect from the section. So here's the physical section, and this is the digital computer unit. You train it from data that comes from the physical system. And guess what? That digital twin becomes smart enough to predict what's going to happen to its twin. The aviation industry does it. Manufacturing industry does it. Power industry does it. There are very real examples. You can look it up where they have created digital twins of an airplane, and the digital twin predict what's going to happen to the airplane with time. Same for roads. We can do this with roads. Can we do it? Yes, we can. This one, real examples where we can do a pavement section, load it, and predict what's going to happen to the pavement on the computer. That picture there, this is like, inshallah ما تحتاجوا, X-ray computed tomography. When you go to the hospital and do X-ray 3D scan, we do it for pavements at 200 microns. 200 microns is a little thicker than my hair. Our human hair is 100 micron. 200 microns. Resolution, we can see what's happening in the pavement at that resolution and detect the types of failure. We can simulate failure in the pavements at a micron level. There's no reason why we don't be ambitious to create these digital twins. And there are efforts, by the way, in Germany, in University of Dresden, they are creating a digital twin of the German road system. In UK, they started talking about digital roads. So there are efforts along these lines. We can even create digital asphalt mixtures. This is done by my PhD student, Danielle Castello, and Caro, you know them both. And they created this one in an effort with us. You can create it, and in the computer test it. You don't have to, everything has to go into the field first. You can narrow the options in the computer. With that, I say, we are adopting resilient and sustainable materials and practice through the life cycle. We need to consider the effect of climate change. By the way, just as a disclaimer, climate change is not deterministic models. There is error around these predictions, absolutely. There's no doubt. And so some people say it's not necessary because there is so much error bar around these predictions. But now we can see in Saudi Arabia, in Kabsark, in Kaust, we have people who are experts in Qatar, in the region, who predict climate change effects zoomed into our cities and towns. Examine the suitability of current design methods. How do they account for climate change? And I think it's not far stretched to develop the digital twins. With that, I want to thank my research collaborators, former and current graduate students and researchers, and the agencies who supported our research. And just put a plug in for my new book that just came out. The second edition, first edition was published in 2008. The second edition, alhamdulillah, came this summer by Wiley on pavement design and materials, where we cover from material selection to pavement design to rehabilitation, maintenance, and so on. So thank you all, and again, thanks for the opportunity.
Thank you, Dr. Iyad. You really drew our attention to how innovation can drive us to sustainable approaches in pavement design. نكمل برنامجنا لهذا اليوم مع المدير العام للإدارة العامة للجودة والبيئة في الهيئة العامة للطرق، المهندس العباس الحازمي، مسلطاً الضوء على ممارسات الهيئة العامة للطرق ضمن أعمال معالجات وصيانات الطرق. رحبوا معي بالمهندس.
السلام عليكم جميعا. شكرا لحضوركم وشكرا للمنظمين على الدعوة الكريمة. إن شاء الله عرضنا راح يكون سريع وخفيف. هو استعراض سريع لأبرز الممارسات التي تقوم بها الهيئة العامة للطرق ضمن أساليب معالجات وصيانة الطرق. في مشكلة في طيب، نعطي مقدمة سريعة عن الهيئة العامة للطرق. هيئة حكومية تأسست بقرار مجلس الوزراء، تتمتع بالشخصية الاعتبارية. طبعا رؤيتها الريادة في تنظيم شبكة طرق وطنية آمنة ومستدامة ومبتكرة. لديها رسالة في تطوير المعايير والسياسات ومتابعة الامتثال لربط المملكة بشبكة طرق رائدة تعزز فيها السلامة والاستدامة والحلول المبتكرة. طبعا لدى الهيئة 5 مستهدفات رئيسية، من ضمنها تطوير أفضل اللوائح التنظيمية لتخطيط وتصميم وإنشاء وتشغيل صيانة الطرق. أيضا توحيد أعلى المواصفات والمعايير في جميع أنحاء المملكة. تعزيز السلامة المرورية على المستوى الوطني، وكذلك مواكبة التقنيات الحديثة والحلول المستدامة والبحث والتطوير للقطاع. أيضا دعم الاستدامة والكفاءة المالية لقطاع الطرق. أيضا لديها العديد من الأدوار التي تقوم بها الهيئة. أبرز ممكنات التطوير في الهيئة العامة للطرق هي وجود وتوفر الكوادر الفنية المتخصصة والمتنوعة. أيضا تمتلك الهيئة ولله الحمد مركز أبحاث للطرق وعدة مختبرات فرعية موزعة على قطاعات المملكة. أيضا الهيئة عكفت على تطوير ووضع كود موحد للطرق، وأيضا راح ينبثق عنه مجموعة من الأدلة الفنية المطورة. أيضا من ضمن أبرز الممكنات للتطوير في الهيئة العامة للطرق هو وجود وتبني التقنيات الحديثة المتطورة سواء في تنفيذ أو صيانة الطرق. عندنا مشكلة، ما أدري. طيب، راح نتكلم عن رحلة الصيانة ومعالجة الطرق المستخدمة لدى الهيئة العامة للطرق. طبعا ملخصة أو متركزة في 4 خطوات رئيسية. تقوم الهيئة العامة للطرق من خلال رحلة صيانة شبكة الطرق بالتوسع في القياسات والمسح وتجميع المعلومات والأضرار. تركز في جمع الأضرار عن العيوب السطحية من التشققات والتخدد وخشونة السطح. أيضا تركز على مقاومة الانزلاق في الأسطح الأسفلتية، وأيضا حالة نعومة السير وراحة القيادة، وكذلك القدرة الإنشائية لقطاع الرصف. أيضا الخطوة الثانية تقييم الحالة الوظيفية والإنشائية للطرق مستخدمة أحدث الأجهزة والمعدات. ترصد معامل حالة الرصف والسعة الإنشائية لكل طريق حسب تصنيف الطريق ونوع الطريق. بعد التقييم وجمع المعلومات يتم تحليل النتائج وإدارة الميزانيات وتحديد الأولويات للصيانة. في هذه المرحلة تقوم الإدارات المعنية المتخصصة بتحليل النتائج ونماذج التدهور والمستهدفات الاستراتيجية. أيضا يتم توزيع الميزانيات وتحديد الأولويات وتحليل دورة حياة التكلفة لكل طريق وكل طريقة إصلاح. الخطوة الرابعة والأخيرة هي تعكف الهيئة على تحديد مجموعة من بدائل الإصلاح وتختار الأفضل، وتركز في هذه البدائل على التحسين في القدرة الإنشائية للطريق. أيضا التحسن أو تحسين في حالة الوظيفية للطريق، وتركز على كون طريقة الإصلاح وقابليتها للتنفيذ، وأيضا التكلفة من بداية الصيانة إلى نهاية العمر الافتراضي. فيديو بسيط عن الأجهزة والمعدات المتطورة اللي تستخدم في مسح شبكة الطرق لدى الهيئة العامة للطرق. إذا يشتغل الفيديو. في مشكلة؟ يبدو في مشكلة في تشغيل الفيديوهات. نكمل ولا؟ عموما يبدو لي في مشكلة يمكن في فيديوهات. الهيئة ومن فترة طويلة استشعرت التحديات القائمة والمتزايدة في موضوع الأسفلت القديم ناتج الكشط. طبعا هذه بعض الأرقام التي توضح وترصد حجم التحدي. التحدي هذا كان أحد ركائز توجه الهيئة لتبني التقنيات المتطورة في أعمال الصيانة. طبعا الهيئة العامة من خلال طرقها ومن خلال أعمال الصيانة تنتج ما يزيد عن 2 مليون متر مكعب سنويا من الأسفلت المقشوط. تقدر قيمة هذا الأسفلت المقشوط بما يزيد عن 850 مليون ريال. لو استخدمنا هذا المقشوط بالناحية الثانية راح يساهم في خفض التكاليف بحدود من 28 إلى 32%. أيضا راح يساهم في خفض الأثر البيئي الضار، وأيضا التشوه البصري. الجميع يعرف التشوه البصري الذي يسببه الأسفلت المقشوط. أحد الأساليب المتطورة اللي اعتمدتها الهيئة العامة للطرق في الفترة الأخيرة هو إعادة استخدام الأسفلت القديم ناتج الكشط على البارد CIR. طبعا الجميع يعرف أن هذه تكنولوجيا إعادة التدوير على البارد في الموقع بدون نقل وبدون تكاليف نقل وبدون زيادة معدات، فيتم كشط وإعادة سفلتة الطبقات الأسفلتية فقط في نفس الموقع وعلى البارد. الحمد لله كانت المستهدفات لدى الهيئة من هذه التقنية هي تقليل التكاليف وتقليل وقت التنفيذ وتوفير استهلاك الطاقة، الحفاظ على الموارد، والحد من التشوه البصري، وتقليل الانبعاثات الكربونية. النتائج المتحققة ولله الحمد حتى الآن من استخدام هذا الأسلوب هو يعني تقريبا إلى الآن وصلنا إلى 10 من أوامر العمل بكميات تجاوزت 3 مليون متر مربع. وفرنا ما يزيد عن 32% تقريبا مقارنة بالخلطات الساخنة. أيضا حدينا في هذا الأسلوب من أعمال الكشط بنسبة 100%، وسرعنا في وقت التنفيذ بنسبة تزيد عن 40%. الأسلوب الثاني والتقنية الثانية التي اعتمدتها الهيئة هو إعادة تدوير طبقات الرصف بما فيها الطبقات الترابية على البارد اللي هي الFDR. تعريف التقنية طبعا هو خلط وقطاع الطريق الأسفلتي مع ما تحته من طبقات ترابية وتقوية الطبقات ثم تغطيتها بطبقة ساخنة جديدة. كانت المستهدفات أيضا من هذه التقنية هي تقليل التكاليف والحفاظ على الموارد وتسريع وقت التنفيذ والحد من التشوه البصري وتوفير استهلاك الطاقة وتقليل الانبعاثات. توسعنا في التطبيق في بعض أوامر العمل في منطقة تبوك. أيضا كانت النتائج المتحققة هو الحد من أعمال الكشط بنسبة 100%، وتقليل وقت التنفيذ بنسبة تزيد عن 45%. وأيضا من هذه التقنية ينتج لنا تحسين في القدرة الإنشائية للطرق تقريبا ب20%. أيضا فيديو بس ما أدري يقدر يشتغل أو لا. أيضا من الأساليب المعتمدة في الهيئة العامة للطرق والتي عكفت عليها وطورت بعض الطبقات الأسفلتية الرقيقة المطورة للمعالجات السطحية، وهذا برنامج اعتمدته الهيئة للحفاظ على أصول الطرق لديها قبل التدهور. أحد الزملاء عرض الكيرف التدهور، هذه أحد الحلول التي تستهدف المحافظة على سطح الطريق والمحافظة على الوظائف الإنشائية للطريق. طبعا كان الفكرة هو تطوير خلطات اسفلتية على الساخن يتم إنتاجها وتنفيذها باستخدام الأساليب والمعدات المتاحة للمقاولين بدون أي معدات حديثة أو جديدة أو تكلفة إضافية أو الحاجة إلى تدريب، فهي خلطات اسفلتية ولكن مطورة بطريقة يعني في المواد وفي خشونة المواد وفي مقاسات المواد. يعني طبقنا إلى الآن تقريبا 40 مليون متر مسطح بتكاليف تتجاوز 40 مليون ريال. التقنية هذه توفر أو الخلطات هذه توفر في التكاليف بأكثر من 28% من مقارنة بالكشط وإعادة السفلتة. أيضا تقلل وقت التنفيذ بأكثر من 33%. أيضا الهيئة توسعت في استخدام ناتج المطاط، ناتج طحن إطارات السيارات القديمة في الخلطات الإسفلتية. لدينا تصميم للطبقة الماصة للإجهادات، خلطة إسفلتية ناعمة تتضمن نسب مرتفعة من المطاط، ناتج طحن إطارات السيارات القديمة وألياف البوليستر. طبعا نستخدم الطبقة هذه كطبقة ماصة للإجهادات لعدم انعكاس التشققات في الطبقات الأسفلتية الجديدة. شاركنا هذا الخلطة مع العديد من الزملاء في البلديات والإسكان، أمانة الرياض، أمانة المنطقة الشرقية وأمانة جدة، والحمد لله لاقت نجاح كبير جدا. الهيئة العامة للطرق كل هذه التطويرات وكل هذه الخلطات وكل هذه التقنيات تعمل بحوكمة معينة، ويعني جعلت أدلة فنية لجميع هذه الممارسات. الأدلة الفنية متاحة ومنشورة على موقع الوزارة لكي يكون العمل لدى المقاولين وشركاء النجاح والاستشاريين بطريقة محوكمة ومقننة في مواصفات وأدلة فنية. شكرا لكم جميعا.
شكرا مهندس العباس، ونود أن نشكر الهيئة العامة للطرق على جميع الجهود المبذولة لصيانة والمحافظة على الطرق في المملكة. أود التذكير مرة أخرى باستخدام الباركود الموجود أمامكم في حال وجود أي استفسارات أو أسئلة للمتحدثين نطرحها عليهم في الجلسة الحوارية، ولتقييم تجربة الملتقى وتسجيل معلوماتكم الشخصية للحصول على شهادات الحضور. أما الآن سننتقل مع المدير الاستشاري لإدارة الجودة في شركة آبلس في الرياض مع وزارة النقل، متحدثاً عن القصة المستمرة في صيانة وإدارة شبكات الطرق. Please everyone welcome Dr. Alan Rudelt.
Yeah. Assalamu alaikum, everyone, and good day. It's a pleasure to be with you today. I don't know how it's working. Can anyone show me? All right? Okay. In my presentation, I will talk about the continuous story about the maintenance management. Maintenance management is a challenge for every single authority, and not just in the kingdom, but all around the world. In my presentation, I will give you some background about our company, A+, and also we'll talk about the infrastructure asset management, give you an introduction and overview, maintenance management, and pavement deterioration, maintenance approaches, and the criticality of road structures. Then we'll talk about the continuous development of this story. Although Dr. Ayad has mentioned about the digital twin, but I'll tackle it from the maintenance management and how it works. We'll talk also about structure and pavement instrumentation, the drones. Then we will talk about the sustainable pavement and the most suitable type in the region. And then we will talk about the key network issues, which is the divert maintenance and the backlog and the funding issues. And then we'll open the discussions. A+ is actually a worldwide company. We're working in 65 countries. Our revenue around 2 billion. We have actually offices all around the world. Main offices in the Middle East, in Oman, in Qatar, in UAE, and the largest one in Saudi Arabia. We're operating in Riyadh and also in Dammam and throughout the kingdom. We have a big portfolio, and we're working in the civil engineering or civil infrastructure, airport, railway, marine, and buildings, and also in the industrial construction. If anyone interested in any of these activities, we'll be very happy to support you and assist you. Now, would like to move to the asset management and the pavement management system, the data collection, and the digital twins. The infrastructure is a key and essential part to any economy. Its support is actually and sustain economic activities. And I'll take the American example. It says, without a modern, expanding highway program, we will not be able to compete. If the American economy is continue to expanding, we must ensure that we have a transportation infrastructure able to maximize the efficiency of the industry. Similarly, in the kingdom is the fastest or the most growing economy in the G20. Therefore, the link between the economy and infrastructure should be actually considered and should be taken seriously. The asset management is a systematic process. It's a start from creating the asset, then operate it, maintain it, and then upgrade it, and then dispose it. Asset management, it's a continuous process. One of these processes is the operation and maintenance. If we look to the barrel on the right side, we never fill this barrel with water due to there are two holes. The two holes are the traffic and the axle load and the environment. So no matter how much you're injecting money and how much you're doing the maintenance and operation, you still need to do it. So it's something you will never ever gonna end it, but you need to do it smartly and effectively. The maintenance and deterioration is linked. And there are different activities or different factors influencing the deterioration of pavement. If we're talking about the environment, which is Dr. Ayad also talked about that in details, the traffic, axle load, heavy weight, the percentage of the commercial vehicles, and also over the time and the type of maintenance will have an impact on the deterioration of the asset. The quality of construction, as I mentioned by Engineer Bass, it's also important, and the pavement type is being used is also have an impact on the way that we are doing and performing the maintenance. As I said, the maintenance and operation activities is divided into 5 distinct categories. Operation, which is the activities that we do it without having impact on the integrity of asset, such as the sand removal, sweeping, road marking, power payment, the inspections, the accident clearance, all these, it could be done just to keep the network and the roads open, but it will never ever improve it or actually adding extra for it. The maintenance is ongoing, whether it's actually routine maintenance or rehabilitation or reconstruction. It could be a pavement repairs, guardrail, minor replacement. Renewals, which is something that is not very or widely used in some part of the world. Replacing like with like. So for example, if an asset been built 20 years ago, by a certain time, it needs to be replaced all or partially, or at least the mill and replace has been done as a part of the renewals. New work, which is actually growing over here, but also the upgrade and improvement is a key component of that as a capital investment. And finally, disposal. When the asset reach its end of its useful life, you have actually to abandon it or to put it aside. Now, there are different approaches for maintenance. One of them is keep it until it fails. The other one is doing the preventive maintenance or doing a corrective maintenance whenever there's a big issue, then you need to intervene and you need to do the maintenance. The other one is improvement maintenance when and where required. And the last one is the most important thing is the predictive modeling. The more we're going to heading to the predictive modeling, the more that it becomes more complicated and complex, but it will yield better outcome and benefit to the agency. And therefore, you are moving from reactive into a proactive mode. This is just a sample of some failure which happen around the world, especially on the structure. Structure and bridges is very critical. And if you do not actually do the proper maintenance, you will have what they call the sudden failure. Sudden failure shouldn't be happen and should be prevented. To prevent it, you need to have the life cycle management, whether for the superstructure, the structure, the foundation, but you need to look to the entire structure in total. Our continuous development for the maintenance and operation is not to re-establishing the system or replace it with something new. It's just to build what we have previously and what we achieved from previous practice. The automating of the process is also part of this improvement. Having said all that, the most important thing is the predictive modeling. Once it's been integrated into your process for operation and maintenance, and now you're moving into advanced level of handling the network needs. Digital twin has already been again by Dr. Ayad, but I just would like to highlight it's important for the predictive modeling. It could be used for the condition monitoring. It also could simulate and analyze the network performance and maintenance. It also provided what they call the remote monitoring. Training and education also could be achieved through the digital twin. Other way of monitoring the network, especially for road structure, putting the swim station or putting the sensors within the bridges, just to provide us with a continuous and early alert that there is something could happen within the network. Pavement and instrumentation, whether you're putting a vertical deflection or you're putting actually the sensor for the strain or pressure or temperature, all these sensors are providing a continuous monitoring for the network. This is an example in Australia, in Brisbane, at the Sunshine Coast. There's a landfill which actually exhibiting a lot of failure due to the high maintenance. And we installed this total station, which is providing an actual and an instant information about the road performance. Again, the drones, the traffic counting, and the other devices which are providing the remote sensing technology. For the sustainable pavement, there are two types. The thin flexible pavement, which has been highlighted again in the previous presentation, the chip seal. The chip seal is affordable, short-term life cycle management, require more frequent maintenance intervention, and in use in countries to simulate the economy. And in New Zealand and Australia, we use it widely. Even in the UK and part of the US, they use it, but I don't believe it's a suitable solution in this part of the world. Now, the deep lift asphalt, or we call it perpetual pavement. This is pavement which is designed to actually achieve 50 years plus. It is designed to last forever, provided that you are actually intervening with the mill and replace at a certain time. And this is actually a solution, while it's more expensive, but is more durable and less effort in a longer term. It also providing a longer life cycle. And using countries where there's a rapid economy development. And I believe, as I mentioned earlier, that Saudi Arabia or the Kingdom is actually the most growing economy in G20. And I believe that this type of pavement is going to be the most suitable and economic in a long term. Now, it also could lead to have the performance specified maintenance contract or to have it in the privatization. Investing in this type of pavement will lead the way to make sure that your investment, it will have the highest return as you go through the time. Now, with all this story, we always need a data. Data is very important for our maintenance and operation. Data could be changed into or converted into information, and then it's transferred the decision-making process. There are two principles of the data collection. Collect the data that you wanted, and collect the data only if required. This also should be relevant, appropriate, reliable, and affordable as well. Don't collect too much data. Don't be ambitious about what you are collecting. Collecting the data which is high degree of accuracy. For example, there are two types of cracking, 1 millimeter and greater than 3 millimeter. There's no need to looking for something with millimeter, which is, there's no solution and there's no treatment for that. So we need to collect the data that it help us to intervene and also to apply the appropriate treatment. Again, in the asset condition monitoring, we look into three items. The safety, we make sure that it provides a safe environment for all the road users. Serviceability, pavement should provide a smooth ride as design speed. Therefore, we are looking for cracking, roughness, potholes, and other patches as well. Structure capacity, will the pavement carry the loads coming especially from the heavy commercial vehicles or from the trucks? And again, the rutting, shoving, and wide structure cracking, depression, and other structure deficiency could be actually highlighted as a part of the structure capacity or structure evaluation of the pavement. Now, how you collect the data? You collect it using the high-speed. I'm not going to actually talk about that because Engineer Abbas, he already spoken about what we are doing at the ministry, which is the collecting the data and inventory. The inventory, which is physical attribute of asset, doesn't change over the time, while the condition, which is attribute of the asset, will change over the time. Every day, the condition will be deteriorate and will go down and down. Now, the falling weight deflectometer is one of the equipment which is being used for the structure assessment. This is an integrated vehicle which could measure the rutting, roughness, texture depth, and also we're providing the video for the cracking, and also could measure the distance as a part of the full functional assessment of the pavement. This is the falling weight deflectometer, which is stopping every 15 or 50 meter or 100 meter or 500 meter. It depends on what level of assessment you are doing at the network level or the project level. It will provide you with the structure number, modified structure number, or adjusted structure number. And it also determines the deflection and the remaining life of the pavement. Sorry. This is the high-speed deflectograph, and I wish this machine or this equipment to be running in here in the kingdom. The system will provide you not only for the structure assessment, but it will provide you with the full view about the functional assessment or functional condition of the asset. Having that will give you a full picture about what the current condition of the network and what is required to be maintained. This is showing the pavement iteration model, which could be all leading to the roughness, whether it's actually spalling, pothole patches, shear failure, all these, or rut, or cracking, all these actually an interacted model which is linking different defects appeared on the pavement. I would like just to stop here and I just take you through this picture. And as mentioned in previous presentation about the top-down cracking. Top-down cracking in the kingdom is very obvious. And the reason of that, the lack of intervention or the delay in the intervention. And as I said, your pavement is being built here as a deep lift asphalt or structure asphalt, which is at a certain time you need to replace the top surface. If the top-down cracking happened, that means the intervention was a bit late or it is overdue. Therefore, to confirm this fact, and it's not bottom-up cracking, which means structure failure related to the crocodile or to fatigue cracking, take a core on the crack itself. If you found the crack from the top down to the bound layer, that means it's a top-down cracking. If it is propagated down all that, that means, if it is coming from the bottom, it will not show the full depth of the core. So it is very important to distinguish between the top surface or to top-down or the bottom-up cracking. Now, after we collect the data, and we know the condition, we know the inventory, and we know the condition, where are we going to put them? We're going to put them into a database. This database, if we use it for reporting, that's the basic asset information system. If we do any analytical assessment, that will be the standard or asset management. Now, we always need to distinguish between the condition and performance. A lot of people are mixing between the physical state of the asset and the performance, which is ability of the asset to meet the service request. And I give you an example on that. You have an intersection, and you just finished the pavement, but you still have a delay or you have a queuing at that intersection, which means that the condition of the intersection is good, but it failed to meet the surface requirement. And there are so many other examples. Probably the road marking. You painted the road marking, and when you measure the retroreflectivity of the road marking at night, you find it is not reflecting properly, which means that the condition is good, and it looks to you good, but it failed to meet the minimum requirement of retroreflectivity of the road marking. it is important that we need, through the system, to keep our network and keep all the roads within the optimal band condition. Yes, we allow some deterioration, and that's the normal life of the asset. And once it reaches a certain point, we need to intervene. Once we intervene with that, it's going to go up, and that we call it the reset value. And then it again will deteriorate. Imagine that if you minimize the red color in that graph, that means your network is under control and you are doing very well. This is just the conceptual view of any system. You have the database, which is for road traffic, bridges, and then you have the data queries, data transformation. You could have the cross-asset optimization, budget scenarios, and the other strategies. So you could set up a very simple, but you could add some modules to your asset management system to serve all type of assets under the jurisdiction of the authority. I found actually a number of authorities, they implemented a system. So they either have a system which is fully implemented, working well, but not used at the full potential, which is, we call it a partial success. Other time, the system is fully implemented, but not providing the expected outcome, and which is, we call it a partial failure. And the total failure when you have a system which is fully implemented, but never completed. There are so many reasons, one factor. For example, the political influence, the leadership, lack of ownership, not fit for the purpose, funding issues, lack of skilled staff, which is a challenging reason, poor implementation, no ongoing refinement or updating to the system. All these lead to have a failure in system, or in your pavement management, or your asset management system, or bridge management system. These systems need to be kept live and need to be updated frequently. So we need to have and adopt an approach, we call it a pragmatic approach. We don't need to implement it with all functionalities, but in a pragmatic approach, we will add the modules which assist us to include all the assets and also to refine the output from it. Now again, this is the dashboard and reporting sample, which is a subsequent of any asset management system, which is very important at the operational level, at the management level, and also at the leadership. Without having this dashboard, without actually summarizing the leaders and the management, they cannot make an informed decision in order to move forward. Deferred maintenance and accumulated of backlog. This is something which is being faced by most of the agencies around the world. We need to know that the best technology will not deliver unless it's been implemented in an integrated environment where there are skilled staff and also policy in place. Adopting the predictive modeling is very important and essential to have a very active and a good output. Now, these tools that we are using at the strategic level, it could help us also to be used at the operational level. But it's most important thing, we need to set up the appropriate budget level in order to make sure that we do not underestimate or we do not have enough fund to maintain the network. And what will happen, we are consuming the structure capacity, or we're consuming the asset, and we are using the resilient values which is associated with asset. We will not find that until we, in a mid-term or a long term, after 7, 10, 15 years, with all the maintenance or all the fund that we injected throughout the network wasn't doing or wasn't yielding the good output. Now, the reconstruction and rehabilitation, mirror and replace, maintenance item, it needs to be seen as a package. We should not just focusing on rehabilitation or reconstruction, but we need to do, and we need to ask ourselves how much we achieve for that. There's a percentage. For example, you need to put at least 1% for the rehabilitation or reconstruction, and at least 3% per year, 3 to 5% for the mill and replace. simple calculation, how you do it. Say, for example, I have 1,000 kilometer of network. And the life cycle management is, say, every 10 years, you need to mill and replace. So 10,000 over 10, I need to do 100 kilometer. And the question to me, or to the authority, have you done the 100 kilometer per year? Or you actually reduce it to 70 and 60, which means that you increase the life of the existing asset and you start consuming your asset. And that will not appear in the first year or second year, but in 5 and 7 or 10 years, you will find yourself, you have a huge backlog and deferred maintenance that you should intervene, and you should clear that backlog before you embark to do further improvement to your network. Works effect and the review of annual achievements should be conducted. Now, for example, I injected 1 billion riyals in the network, and I did the routine maintenance, the corrective maintenance, the mill and replace. I need to assess how much that works effect been impacting on my network and how much that improving the quality and the performance of the network. Now, it's been found that in developed countries, strong policy framework in place and commitment for rehabilitation and renewals are good and better understood by the politician when they have a policy in place. So we need to set this policy, so when we put the budget bid, or we ask the Minister of Finance for any support for our bid, we will have enough justification to achieve that. The optimal funding allocation and distribution, again, this is another challenge where we need to set up this level, appropriate level of funding, and agencies always, it's not just, I would say, in the GCC or the Middle East, but always around the world, they underestimate that because there are some calculation they calculated, it wasn't covering everything. So we need to make sure that when we are asking for a bid, we have enough and sufficient calculation for that. Often the allocation will be below the network needs. So for example, you ask for 1.5 billion, you will say, okay, you will have 1 billion. Or last year you have 1.2, I will give you 1.3. So the budget will play also a big role in that. But the most important thing, as I mentioned, we need to keep the network fluctuating and within that optimal band condition. Lack of the maintenance record. A lot of agencies do not actually keep this record to help them to planning and to determine this requirement for funding. And finally, the cost of repairing a bridge, for example, it could cost 10 times the cost of the road network. And therefore, we need to have 2 separate budgets for the bridges and road structure and one for the roads. So in conclusion and in the way forward, we would like to see it as a total package. Start with knowledge, through the knowledge of asset, control the long-term strategies, manage the medium-term measure activities, schedule short-term repair as a quick wins, and also improve the efficiency and resources usage. That will ultimately reduce the total cost of operation and maintenance, and it also consider a big picture and always audit and review the network performance. Improve the asset management system, including the bridge management system and pavement management system, and establish the research and R&D. R&D is very important. What's the organization need? And that could be done at the country level as a national strategy and could be cascaded for the region and could be cascaded by the organization. For example, to the Ministry of Transport, to the municipalities, to MUMRA, to different agencies across the country. And again, they review and improve the total budget and funding allocation distribution. Now, I don't want to say that, but this is just a conclusion about technical advisory services. We could do the network data collection. We do the pavement and bridge management consultant services. And also we are doing the the network maintenance and management tasks and activities, including the performance specified maintenance contract. And I will talk about that hopefully tomorrow morning, and I'll give you an overview about all that. Anyone would like to have a question or an email, I would be very happy to receive it on this contact details. Thank you very much. Thank you for your attention.
Thank you, Dr. Allen. وقبل أن ننتقل إلى جلستنا الحوارية مع المتحدثين، رحبوا معي بمدير إدارة الرصف وتقييم الطرق في شركة A+ أريبيا، متحدثاً عن التطور في أساليب التقييم غير المتلف لصيانة البنية التحتية للطرق. Everyone, please welcome Dr. Mario Manosalvas.
Thank you for sticking to the end of the presentation. I know that it's I'm going to be the last step before we go into the launch, so I'm going to try to keep it simple. First of all, I want to thank the organizer for having us. I think it's very important, this type of dissemination that we're doing, so the organization, thank you once. My name is Dr. Mario Manosalvas, and I'm leading the Road Assessment and Payment Management Department at AP+ Arabia. Throughout this presentation, I'm going to present the advancements in the non-destructive evaluation methods and the link to road infrastructure maintenance. Within the presentation, I'm trying to put just what is like a good, fair, and poor performance and how that links. So far, and it is in my personal view and experience, that once we construct a road, then we tend to leave it to its own. We are lacking the maintenance. And then we have different values I just put for some reference, like let's say that greater than 80 could be a good performance, 80 to 40 fair, and of course this would vary depending where we are. So within the content of my presentation, I have tried to divide it as you can see it. Within the introduction, I'm going to explain the key elements of road sustainability. I would also dive into the difference between payment design and payment performance. Then I would go and say, like, what is the need for moving into a data-driven decisions? I would take you to the difference between the traditional payment deterioration models and why we need to do something. And that need is actually the non-destructive testing technologies, and that will be the main topic of the presentation. I would take you to one of the experiments that we did in the UK, where we did a smart payment monitoring system. Then I would zoom in back into the KSA. We did a literature example, and we did an enhanced review of more than 120,000 kilometers of the road network, and how we use that data into calibrating the current deterioration model. Of course, then I'm going to try to wrap it up in future directions, and of course, taking some of the conclusions. So what is SRM? So the sustainable road maintenance ensures three things: longevity, sustainability, and efficiency of road transportation networks, right? So why it helps? Because it helps improve the practice that they prevent infrastructure, minimize environmental impact, and also optimize the resource utilization. I have tried to create this lighthouse that it's at the top of it is the recycled materials, but everything starts what we are doing right now, which is the community engagement. Because we have one topic that we want to discuss, and of course we are eager to understand more of the things. So within that, we have the stakeholder involvement, the regulatory frameworks, and scientific outreach. And I have classified the different lighthouse or the pillars into the LCA that it was mentioned by the previous speakers. We have innovative repair techniques, sustainable materials, PMS, non-destructive testing, preventive maintenance, and recycled materials. And within the recycled materials, I am mentioning the reclaimed asphalt that it was mentioned by Engineer Abbas. We also have the reclaimed asphalt aggregates, reclaimed plastic that it was mentioned by Dr. Massad, and of course we have some byproducts of the blast furnace and the fly ash. The one thing I just want to mention here is that we shouldn't be thinking that these these techniques are new. For instance, the reclaim or the rubberized asphalt concrete, this was already studied in the 80s. There's some research that was done. What has happened to now is that we have the techniques to implement those solutions, and that's why we're doing it. So that's actually a very good thing for us right now. When I said that I want to dive into the comparison between traditional pavement design and pavement performance, is because we all know, and some of my previous speakers, they have also mentioned it. So in order to have an effective pavement design, then of course we need to understand what are the software characteristics. We need to understand the traffic loadings. We need to know the environmental factors and how those are changing, material properties, design life, and we also need to validate the new techniques. Nowadays, we are implementing different materials, different techniques, so we need to have an actual validation of that. We need to have how those interconnect between and how we have this effective. I have also created a table that tries to summarize what are the difference between the design and the performance. If we go into what are the parameters, when we do the design, we do an estimation of the traffic loading. More often than not, those estimations are not valid. And that is an issue of the rapid deterioration that we are seeing. Also, the material properties, we tend to do estimation. There's a quote by Professor Molenaar from DTU Delft that when we do these material samples, we don't get the results from the material, we go from the sample. So there's a very different performance between them. Environmental factors and how they are changing, and the environmental impact that Dr. Mesad mentioned, and it's very important that we need to take in condition. And of course the software conditions, because it changes when we do them, for instance, the FWD, even though I'm gonna mention it later, it changes when we do the FWD, we do it at summer, winter, and it, I mean, in the Saudi, in the kingdom might not be a main difference, but if we do this kind of testing in the US or in the UK, then we have the toll cycling cycles, so it would affect what's happening. Why I'm saying that there's a need for data-driven models. Nowadays, we are flooded by information. Simon, in the first lecture, he mentioned about the traffic speed defectometer and how we can actually collect both functional, structural, and safety indicators in the same machine. So imagine the amount of information that we are collecting. If we are actually thinking of doing something with that information, then we need to go into a more data-driven approach. And I'm trying to create one difference. For instance, with the traditional deterioration models, we do simplified assumptions. We have a lack of real time. And I was mentioning with the other speakers, because that's the main issue that we have. And why is the main issue? Because if we do NDT at the moment, and we do it with a frequency every 6 months, 1 year, 2 years, then we only get a snapshot of the condition of the pavement. And that condition would be valid for those specific conditions on that day. So that's why we need to go into data-driven, or that's at least my approach, when we have real-time monitoring, where we can actually implement some of the different sensors, IoT, that's basically some of the trending information that we have, and I'm going to present it later on in my slides. Then if we have real-time monitoring, what's allowing us? It's allowing us to actually do some predictive analytics. And within the predictive analytics, then we can actually have a better understanding of the pavement. And through them, if we actually join those two, then we can actually, and that's the topic of this conference, we can do a customized maintenance. We need to understand what's happening with the pavement structure in order to fully understand. And Of course, then this leads us to AI-driven inspection and digital twins. And one thing that I'm actually happy is that within the different speakers, we're going into the main concepts. Dr. Ya, Dr. Alan mentioned about the AI inspection, the digital twins. Digital twins, there's an effort that is being led by Cambridge University in the UK. And in my view, the digital twins, even though they're a replica of the condition of the roads, we haven't maximized we haven't utilized its full potential. Why I'm saying that? If we take like drone technology, we do to the roads, we have different surveys, and we have a beautiful model on the computer. But if we don't simulate future performance, then we're not actually using the digital twin. It's just a tool that allows to visualize the information. But we need to put different traffic. We would need to put, as Dr. Ian said before, we have try to put environmental conditions, so we can actually see what we can obtain from the digital twin information. This is, for me, one of the most important slides that I will have in my presentation, and it's because in here I'm trying to focus between the pavement deterioration curves, and I'm saying the traditional curves. There's these two, in the left-hand side, there's from the TRV, a publication from 2011, and in the right-hand side, there's one from the FHA from 2013. And as I said, once we construct the pavement, we tend to let them to deteriorate. We assume that it should last for like 16% of the period until we have to do a preventive maintenance in order to do a major rehabilitation or reconstruction. But the question that I always ask in myself is like, why do traditional pavement deterioration curves fail to account for the road user and environmental stressors, and how we can improve the reliability of our future maintenance planning? And of course, my presentation is about NDT, so that should lead you to the answer. So in my view, NDT should allow you to have a better understanding of how we can evolve from these traditional deterioration curves. Within the AP Plus Asset Management Services, we have more than 30 years that we have been presenting this type of solutions, and I have divided into two main groups. The first one is the road asset inventory and the pavement condition. And within the pavement condition, we have pavement roughness, surface distresses through the LCMS, we have the lane marking, and why I'm saying lane marking would be useful. Maybe not now, but within the next 3-5 years, it will be very important that we pay attention to the lane marking. Why? Because autonomous vehicles are coming. And when we don't have information from the GPS, especially in tunnels, bridges, we will not be able to guide the vehicles. So we need to have a good information from the road marking. Skid resistance is very important because it links to one of the conferences going to be tomorrow related to safety. The structural capacity, FWD, HWD, the TSD, or the Raptor, and of course the ground penetrator radar. Within the asset inventory, there's more for the asset extraction, point clouds, and how the information can help us. I'm just gonna go into a quick information between 4 parameters: the structural, functional, safety, and visual. So within the FWD, there's a quick demonstration on how the principle of the FWD is working. So basically, we go into one of the locations. We mentioned about the frequency. We have to position the equipment. We have to lower the weight. We raise the weight into what we want to test. The different weights needs to mean something. Why we use 40 kilonewtons or 50 kilonewtons in the road is not because it was just assumed. It's because we want to simulate the traffic, or we want to simulate the trucks that pass into the roads. And of course, we need to have we raise the load plane and we move to the next location. If we are seeing here, we have the deflection basin. And the deflection basin is nothing more than the maximum response after applying the load impulse. We need to do something. In this slide, I'm trying to highlight that if we only assume the maximum response, we are missing a lot of information. And that information is being shown by this 3D graph, that we have the time in milliseconds, we have the geophone spacing in millimeters, and of course we have the deflection value. If we actually look at the 3D profile, then we can grasp a lot more information than just on the maximum value. So now we have the tools to actually do something more. This was amazing if we only want to use the basin 30 to 40 years ago. And some of us, we use the different equipment, not the FWD, the equipment before that. So I'm just trying to highlight the need. Once we combine, it's not only about doing the FWD. If we combine that information with the GPR, then we can see a radiogram in here. We can see how the destructive testing comes into play. Because within the destructive testing, we have the actual possibility of calibrating the different dielectricity that we have in the pavement. And I'm just highlighting different standards I definitely recommend, the LTTPP for the FWD measurements, the Ashton measurements, and of course the ASTM D4695 that is involving for the measurements. And of course, the other thing is like now as pavement engineers, we have evolved. We have done more than traditionally things. So in the last hand side, this is a representation of a runway. So we have, it's a small runway that is around 2.2 kilometers, but instead of showcasing the information into 2D plot, I'm actually trying to merge that information because it would allow us to understand where are different zones that we need to do the different maintenance. So that's the idea with that. In terms of the RSP, or the road surface profilometer, I'm trying to put a timeline within the different developments that had happened. So this started with the 1920s, and I'm sure all of us, we have used the road and level when we were doing these studies. And that has evolved until, for me, a key point is the 1980s when the inertial profilometers were put throughout to the users. There's a great study by the World Bank, and that's how they classify the different profilometers. Then I'm also trying to highlight what's the difference between the longitudinal and the transverse profile, how can we use them, and of course, how we can measure. If we are familiar with the string theory, then you know that you need at least minimum 5 lasers in order to calculate accurately the routing. And why the RSP is important? Because it's the only parameter that the user can actually sense. If the user is driving at 120 kilometers per hour, do you think they will be able to sense the percentage of cracking? Of course not. But if they are moving into 80 kilometers, 100 kilometers, and they see that there's some bouncing in the road, their experience is like, no, this road is in a poor condition, and that might be misleading. And at the end, there's also an AP Plus in-house software that we developed, and it's trying to highlight 2 things. Now we are collecting the data every 10 meters, 20 meters, but what happens if we go to 25 millimeters? So we have collected this information at every 25 millimeters, and it's only showcasing 1 kilometer of the road, so from KP25 to KP26. And now it's not only about the IRI. The International Roughness Index is just a product of the profile. So we need to go back, and we actually need to understand how that happens. So we need to understand to the velocity, so it's on the blue line, and also the acceleration, and why those 2 things interact with each other. So for instance, if we see around KP 25.3, then we see that there's like a difference in the acceleration. That difference in the acceleration is, of course, influencing the value of the IRI. It doesn't mean that the pavement is in a bad condition. It's just saying that there's some difference in the profile. So we need to understand. We need to dig a bit deeper into the information that we have and how we can use that. For the LCMS, I'm going to go very, very briefly because it's being presented by the other speakers. Nevertheless, the main components of a multifunctional vehicle, or LCMS, are presented here. You need to have the right-of-way cameras because you need to understand which are the effects that you've seen. You need to have front beam, you need to have a DMI, or like a distance measurement instrument. You need to have an integrated data collection software, and of course the LCMS. Why I'm saying here, in the right-hand side, I'm putting 2 ASTMs. The D5340, which is for airport pavement evaluation, and the D6433, that is for road and parking lots. Within that, it's been detailed the different 19 and 16 distresses that we have for each of the airports and roads, how we need to classify them, how we need to measure, and of course that information needs to be fit into the van that we use in order to have the classification. And there's just an example of how we can visualize that information. We have some patching information, we have cracking information, of course we have the visual view and the information regarding the distress levels. In terms of friction testing, this is related into a safety parameter, which is very important, especially in countries where there's a lot of drain. So in here, I'm trying to just highlight different standards of ASTM. For instance, there's the ASTM E274, that is for the full tie size, the 1551, and of course we have the Federal Highway Aviation in order to do the measurements and reporting. In here, I'm also presenting the different values of the same airport. But we need to understand something. Within the airport that we have a stretch of 2.2 kilometers, we need to measure in different alignments, plus 3 meters to the right, 3 meters to the left, and we need to understand how that it affects it. And those values that we see, green, yellow, and red, are actually friction levels between the MFL, the minimum, the maintenance planning, and the new design. So we have different values, different speeds that we need to target, because in the roads we need to do at 65 kilometers per hour, whereas in the airports we need to do at 95 kilometers per hour. But now that we have all this information, I mean, I'm just describing that because it has to lead to something. If we tend to use one single indicator to understand the condition of the pavement, then we are maybe not considering the right approach. If we are floating into huge amount of information that we have different equipment, so we need to combine that information. So for instance, in here, I'm putting the IRI, the rotting, the friction, the PCI, and how those different parameters, different indicators, they talk to each other, because they have to talk to each other. It cannot be a section that there's a huge, a good value of PCI, but there's like a bad riding quality. So no, there has to be this information, and we need to have thresholds in order to validate this information. So that's the idea. We need to have the information, we need to combine them, and we need to actually see how these different indicators talk to each other, and it would allow us to have a better insight into the payment. Now I'm going to take you back to, I want to take you to the UK to an experiment that we did. It was called the Smart Payment Monitoring System. This experiment was funded by the National Highways at that time, back in 2020. And the idea was to deploy cell power piezoelectric sensors in order to have an early detection. Every time that we say that we want to do some maintenance, we need to understand when the damage is actually happening. So in order to do that, we developed something with Michigan State University. There's the type of sensor. We have a piezoelectric membrane. We did a 200 millimeter course in a different section that I would just present it later. But the idea in here that I want to transmit is like, we know as pavement engineers that the damage will start from the wheel pads. So there's no reason that we should install the sensors outside the wheel pad. So that's why just trying to highlight the wandering effect that we have with the left and wheel right pad, the line width, and we assume, or we tend to believe, that our variables will constantly change throughout the service life of the pavement. And of course, it's also believed that most of the variables would follow a normal distribution. So the only way to track that distribution is by having a constant measurement, like continuous measurement. So why this is linked into the big data, like one of the words that we like to say now, because the frequency that we were using to collect data, it was at 800 hertz. That means that each point that we were collecting to the figure that you see in the hand side right, it was at 0.00125 seconds. So why we want to do that? Can we just go into 1 hertz per a frequency of 1 hertz? We could, but we will not be able to collect this information. We will not be able to detail the information. So why is big data analytics? Because the data will grow exponentially. So within 20 minutes that is being shown in this plot, we collect around 1 million points. If we extrapolate that information into one day, we will collect 69 million points for one sensor. We deploy 12 sensors. So imagine the quantity of information that we're going to have. If you're giving with that type of information, then of course you need to move into a programming language in order to do the understanding of the data. Otherwise, it would be impossible to do it. So in here, rapidly, is how the installation was done in the UK. So we selected 3 different highways. We selected the A66, the I-19, and the A1. The 3 of them are major roads in the UK. And you can see something here is very important. You can see the thickness of the pavement. The thickness of the pavement goes from 250 to 350 millimeters. And the condition of the pavement when we extract them was in a perfect condition. So without signs of damage or deterioration. We can also see the temperatures that we use, and you can see that there's a difference between the three experiments, and that difference is between the spacing that we use. In the A66, we use a 1.2 meter interval between the cores. And why we use that? Because we want to test the location. If we know the position and the physical location and the distance and the signal, then we can get the velocity, right? So that's why we wanted to do it. The other thing that I want to highlight, and if you grab attention to the middle part, you can see that the sensors were not placed in a straight line. They were placed with a different wandering because we wanted to follow that. The responses are going to follow the normal driving behavior. These are 2 videos. I hope that I have more luck than Engineer Abbas in highlighting them. Okay, good. So within these 2 videos, what I wanted to show, we created a slow motion, and this is the A66. So we want to show if we can actually capture those vehicles when they are passing, and if we can actually capture within the signals. Of course, we can actually see that we have different configuration. We have light vehicles and we have heavy goods vehicles. So, of course, when we do the pavement design, what do we say? We don't even consider light vehicles when we do the 4-power law or whatever into the traffic analysis. We only focus on heavy goods vehicles, right? And then let me show you how that actually replicates. So in here, on the left-hand side, within the center, the one causing the greatest damage is one of the heavy goods vehicles. And we can actually see them, and then when we go to the light vehicles, then we see that the response of the magnitude response is very minimum. Nevertheless, within the approach that we have developed, we don't focus on the maximum response, which is completely opposite of what we do as pavement engineers when we focus on the maximum tensile strength. That value we focus in order to decide if there's cracking or the pavement has failed or not, or if we're going into a perpetual pavement, if we have less than 120 microstrain. We don't care about the maximum strength. We care about the concept of energy harvesting that I would explain. So if we have 3 different sensors, why we are not collecting within the same time frame? And it's because of the position of the sensors, how they are passing the difference. So we are collecting at the same time, so depending on where they are, we can actually understand each other. And one of the byproducts of this example is how we can actually do some vehicle counter and damage detection of the pavement. So within that, we were able due to the high frequency of the sensor, we're able to replicate the signals. And of course, we have a two-axle vehicle, 2 configurations of 3-axle vehicles, 4-axle vehicles, and so on and so forth. And of course, we create a Python program in order to calculate that. And as I said, for us, the most important thing is not the absolute response, it's to actually see when the damage is occurring, because when we know the damage, then we can actually act into the pavement. I want to get you back into the KSA case study, and I would like to thank the Ministry of Transportation and especially the General Manager of the Survey and Assessment, because this one as a study that we did it back in 2022. And within that study, we collected more than, or approximately 120,000 lane kilometers, And within that, we collect data from 2014 to 2020. And we collect that data into principal roads. So we went to road 40, 10, 15, and 65. And in the right-hand side, you can actually see the distribution of the road. So within road 40, with a length, or with a total length of 1,335, we distributed the number of lanes, the kilometers, and the service. So that's the information. If we have all this data, then we need to have a rapid way of understanding the data, and there's nothing better to understand all this data than histograms. Within the histograms, we can see that 78% of the data has a IRI below 2.0, 94% of the data is below 3.3 meters per kilometer. Why I'm highlighting those values? Because those are the values that sometimes are used by some institute to collect or to detect the threshold. For instance, in the routing, 71% of all this data between 2014 and 2020 were below 5 millimeters. So it was something that Dr. Allen mentioned before. So like in the design of the pavement here in Saudi Arabia, you have done an excellent job into tackling the routing creation. So we can actually see within these values. Once we have done all these data mining, we actually propose two different deterioration curves that reflect to the condition of the Kingdom of Saudi Arabia. And we have called a normal deduct value, a high deduct value. And this actually helps us to improve the calculation and also reflects the on-site condition. And I highlighted three examples in here, road 40 and road 6, and there's like a feeder road, 6673, where we have the different indicators. For instance, in road 40, there's one road that has been just recently repaved, but of course, once we have an IRI of 2.3. The current value that we have estimated is 68. Once we apply the new or the proposed methodology for the deterioration curve, we say that it should be 90. Why this value is important? This value is important is because if we use the value of 68 for that condition and we feed that into decision tree, then basically we're saying that we need to do another maintenance there. And that will be completely detrimental into the maintenance. And there are the other two cases. And these are just validation, because when you do modeling, you know that validation is the key. If you have a good validation, then of course that means that you are more towards to the reality. So we have highlighted some cases that all model estimates a higher condition, and some cases when the OR model estimates a lower condition. So we are presenting different type of the condition, some rural roads, some feeder roads, dual roads, so trying to just like get an overview of everything. In terms of what's to the future, what are the different directions? So we cannot say that one single deterioration curve can understand or can be valid for the entire kingdom. That's not logical, and no one who should say that. But how we can actually move forward, now that we have a way to actually understand the values of the road network, then we need to go into the engineering road classification, and there's an example of the express, dual, and single roads. Then we have the geological characteristic of the material when we split between the Arabian Shale and the Arabian platform. And of course, we have the super paved temperature classification. We have the zone A, B, and C, and how that's being distributed. In here, we have a zone A, so it's the highest temperature. Then we go into the middle of the kingdom. We have zone C, and between the middle part, we have zone B. Once we have done, we have run around 120 simulations in order to distinguish between how we can do the classification. We have done, for this just example, just for the expressways. So we have to classify. Are we going to do it for truck lanes and other lanes? So this is just an example. I just finished with this because this is linked to the maintenance. So once we collect all that information, how that links into what we need to do it. And this example is trying to show, I hope you can see it, but it shows on the left-hand side the IRI, the classes before maintenance. Then we have applied certain maintenance, and then what's the IRI after the maintenance? So what we're saying is like we have chosen an alluvial plot in order to have a better representation of the data, because it allows us to actually see how the data trends. For for example, when we have a new construction, of course, we emerge as the most effective solution because that's the one that reduces the IRI when it's greater than 4. And the other thing is, like, we need to see how the IRI evolves per year. So once we have applied a maintenance, how that would increase year by year, because that's also allowing us into the different decisions. My final remarks, of course, I don't believe the static deterioration curves. They fail to account for dynamic factors, and of course, we need to change them. Reactive approach often led to inefficiency and high and long-term costs, as we have discussed within the other speakers. And I believe that NDT provides a real-time precision evaluations. Then, of course, we have how we can integrate NDT within the PMS and how it helps us. It helps us to enhance the ability to analyze the data, facilitates proactive maintenance, and also optimize the maintenance schedules. In terms of the advantage of data-driven, of course, it combines this technology, enables real-time, and supports sustainability. That is something that we need to take very seriously. And, of course, linking NDT with the modern maintenance strategies allow us as engineers to put the infrastructure. Thank you very much.
Thank you, Dr. Mario, for the session. شكرا لجميع الخبراء الذين أثروا برنامجنا لهذا اليوم. أما الآن سننتقل إلى الجلسة الحوارية مع المتحدثين للإجابة على أسئلتكم. I'd like to invite all the speakers on stage so we can start our panel discussion. Welcome everyone on stage. قبل لا نبدأ نود أن نعتذر على الخطأ التقني اللي صار خلال محاضرة المهندس العباس، ونود أن نستعرض الفيديوهات للمحاضرة، ولربما المهندس يود التعقيب على الفيديوهات.
الفيديو يشرح المعدات المستخدمة لعمليات المسح والتقييم لشبكة الطرق. عندنا اسطول كبير من المعدات، يمكن أكبر اسطول في الشرق الأوسط في معدات المسح والتقييم. الفيديو الثاني
نستعرض الفيديو الثاني.
الفيديو الثاني طبعا يستعرض التقنيات إعادة استخدام الأسفلت المكشوط في الموقع. اليوم الحمد لله المعدات هذه كنا نشوفها في دول العالم. اليوم الحمد لله 3 من مقاولين المملكة العربية السعودية يمتلكون المعدات هذه، وتعمل الآن في مشاريع الطرق في المملكة العربية السعودية. يعني هذا فخر لنا جميعا الحمد لله.
شكرا مهندس.
العام الماضي أطلقت الهيئة العامة للطرق تقنية إعادة استخدام الأسفلت. اليوم الحمد لله تطلق الهيئة العامة للطرق تقنية إعادة استخدام الأسفلت وما تحت الأسفلت. هي تقنية نظيفة ما فيها أي انبعاث كربوني، السرعة التنفيذ فيها أسرع من العمل التقليدي، والحمد لله وقفنا على هذه التجربة اليوم. هي عبارة عن 4 مراحل، والحمد لله تجربة ناجحة ستتبناها بإذن الله الهيئة العامة للطرق.
التفاصيل الفنية للمعدة أو تفاصيل عمل المعدة تقوم بحرف وتقليب طبقات الأسفلت القديمة المتهالكة مع طبقات الأساس ما تحتها في خطوة واحدة، تختصر مجهود كبير من المعدات من إزالة الطبقات وإعادتها مرة أخرى، فكلها تنعمل بخطوة واحدة، وهذا يؤدي إلى تسريع الوقت وتقليل المعدات والتكاليف، أيضا الحفاظ على البيئة بشكل كبير وعلى استدامة المواد، لأن يستخدم نفس المواد الموجودة في الطريق، وتنعمل بطرق يعني تقنية معروفة بتصاميم معينة. اليوم الهيئة العامة للطرق يعني وضعت أدلة فنية بواسطات اشتراطات، كل هذا تسهيل لانطلاق التقنيات الحديثة هذه.
طيب ممكن نبدأ مع المهندس في أول الأسئلة. هل الرصف على البارد يراعي التصميم السابق للطريق؟ أم أن الطريقة والآلية نفسها تعالج الخلل في الأسفلت القائم بناء على بيانات معينة معطاة للنظام ويتم الرصف حينها؟ وهل يؤثر على منسوب الطريق؟
إعادة الرصف على البارد هذه تقنية عالمية معروفة، ما احنا أول ناس ولا آخر ناس أعتقد راح نستخدمها. هي تعالج تحديات عندنا. أولاً التحديات تراكم كميات الأسفلت المقشوط وتأثيره على البيئة وعلى التشوه البصري. أيضاً الأسفلت المقشوط احنا نعتبره ثروة يعني، وله قيمة، يحتوي على أسفلت، يحتوي على ركام جيد خدم في نفس الطريق. يعني يمكن يعني أول أو أكبر خطوة أنك تحد من تراكم المقشوط هو استخدامه في نفس الموقع وفي نفس الطريق. فيه آليات كثيرة، في طرق كثيرة من ناحية دراسة وضع المنسوب وبنفس المنسوب أو بارتفاع بسيط مدروس. كل هذه يعني موصفة وموجودة في الدليل الفني المطور من الهيئة.
شكرا، يعطيك العافية. I'd like to ask the next question to Engineer Simon. Are there any ongoing research projects focused on integrating real-time data collection for predictive pavement maintenance and its life cycle?
Not that I'm aware of, no, but I mean everything that we are doing is geared up to doing exactly that. Mm-hmm. Once we can get that going, that is the point, predicting what is going to happen in the future and modeling this thing. And the more data we have, the easier that job's going to be. So that is the ultimate aim, obviously, and that's where we would like to get. But no actual project that I know of. I'm not involved in anything of that right now, but that is where we're going to go. There's no doubt. And that's the whole point.
Interesting. Thank you, Engineer. Maybe we can move to Dr. Lee for the next question. You mentioned in your presentation a new materials for repair roads. Can you mention some of that materials?
Sorry, can you repeat it?
Yes, I can repeat the question. You mentioned in your presentation a new materials for repairing the roads. Can you mention some of those materials?
No, I didn't get your question, sorry.
Okay, maybe we can move to the next question.
Okay.
Yeah. Is JP 6000 suitable for Saudi Arabia hot weather? Plus, what's the production capacity for JP 6000?
Yeah, it's a good question. And first of all, the JP 6000 is right now standing on a good position in terms of the advantage compared to the machine used for hardening in-place recycling. as I mentioned in my presentation, the environmental, they keep the temperature higher up to 140, which is perfect pavement temperature. So the other one is the smoking, the environmental. The emissions has been completely treated. So with this three portion, this is already the very high advantage. Plus the other one is from the Ontario road, the evaluation or bidding process, green roads scoring system. Okay, as I mentioned, in total, like 4 categories, total score 36 points. And that involved design and construction, environmental, and innovative design. So those are passed that one, 16. And so the answer to the question is suitable to Saudi Arabia, mostly.
Yeah. Thank you. ننتقل إلى الدكتور إياد. كيف يمكننا الموازنة بين الحاجة للإسفلت وارتفاع درجة الحرارة عالمياً وتأثيرها السلبي على المناخ؟
طبعا the asphalt or bitumen is temperature sensitive, so we know that, and it's known that it's graded based on the temperature that it can sustain. The challenge, what we're talking about, that if we select the materials, the bitumen, based on current temperature profiles, this selection may not work in the future because the temperature profile is changing. What does this mean? For example, if you take the eastern province of Saudi Arabia, Qatar, I believe the PG grade here, for those who know on the asphalt, is PG 76. And in expressways, we use what's called PG 76E, extreme condition. There is no much room to keep increasing these grades in terms of the current technologies. So we have to look for new technologies to improve sustaining temperatures without getting the bitumen stiffer and stiffer and stiffer. Because if we do that, I think Ronald talked about it, that it's obvious in Saudi, the top-down cracking. This is actually in the entire region. And some of it because we push too far into increasing the stiffness of binder without adjusting our mixed designs to accommodate it. So they go side by side, picking which item we adjust without looking at the whole system can actually has adverse effects rather than help. So the short answer is continue to look for sustainable innovations in improving the bitumen resistance to temperature, instead of keep adding virgin materials to increase that resistance.
Very clear. Thank you, Doctor. And now we can move to Dr. Allen for the next question. What's the components and the specifications of perpetual asphalt?
Well, the perpetual asphalt have two key components, bound layers and unbound layers. The unbound layers is actually a sub-base material, usually between 150 to 100 millimeter. It could be done at the 2 layers. And then the asphalt is actually 3 layers, which is the surfacing, the binder, and the stabilizer layer. In total, in some places in the GCC or the Middle East, could go as high as 500 millimeter, or even could reach around 600 millimeter, which is actually almost very rigid as a runway. The fact is, I carried out some tests for the structure analysis for some of the roads in the GCC. I wouldn't say which country, but in some of the GCC, I found that the structure capacity available with some roads is even higher than the runway itself, except the roughness with the runways should go between 0.4 to 0.5 IRI. But in terms of the structure capacity, the deflection was almost 0 or none.
Yes, of course.
100% agree with Ronald. I want to add the concept of the perpetual pavement, which are initially expensive, is that you push the problem to the surface. So the idea that you can fix it, clear or correct the surface without going through expensive work in the deep. So initially it's expensive, but on the life cycle cost, I agree with your statement that you made 100%. I think it's a good solution for our part of the world because we want these roads to live 50, 60 years. At the same time, we don't want to make major rehabilitation for them. One caveat for this, I wish if in this region we make correct our design, the mixed designs for the surface mixes. Just as a note, I think there's improvement to do that to help our surface mixes.
Yeah. I just would like also to add something. I don't see any reason why the GCC cannot implement such a solution. The bitumen is valuable. The aggregate material is also available, especially in some areas, like if you go to the western region, which is Mecca, Medina, this is a good type of material. And also the resources in terms of the labor and in terms of other supply. So in my opinion, this is a way forward, and it will be a cost effective, and in long term, it will provide you a good return on investment. Thank you.
Thank you, Doctor. Yes, of course. Maybe you can push the button so you can.
It's down.
Yes, we can hear.
Okay. Yeah, sorry. Okay, the perpetual pavement is now defined over 50 years for service. And it's now the people talk about, okay, if you have a strong structure that's strong enough, and we only keep the top surface, like 2 to 4 centimeters or 50 millimeters. This could be every 10 years, every 20 years, you can repave, because that cannot be avoided because the materials exposed to the traffic, exposed to the environment should be deteriorated very fast, 10 years, maximum 7 years. That's the reason introduce the holding in place recycling. And adding one more words about the previous question, adding the number 5, the why that could be used, the hot in place used in Saudi Arabia because of temperature, natural temperature. That could save lots of energy to burning, to heating the asphalt. That's the medicine. Okay, thank you.
Yeah. Thank you. And now we will be moving to Dr. Mario for the next question. Are there any research initiatives focused on autonomous or robotic systems for road repairs and maintenance?
That's a very good question, and actually the answer is yes. University of Birmingham in the UK, in collaboration with University of Nottingham, they started this program where they actually start doing some pilot projects to deploy robots to do a pothole repairs. So yeah, the short answer is that yeah, the University of Birmingham and one of my colleagues at the University of Nottingham, they were also leading that effort. So it's actually something that we need to move forward. At certain stages, there are certain countries that they are towards into that methodologies. The idea of the benefits of this, it will be to remove people from site. As we have said, or we have mentioned during the presentation, having people on site is expensive and it's dangerous. And that's why we're going through automation. So we need to try to keep that in mind and in order to apply this type of different solutions.
Clear, thank you. نعود للمهندس العباس في السؤال التالي. طبقة الأسفلت مع المطاط هل يتم عملها بدون معالجة التشققات؟
يمكن السؤال يقصدون طبقة الممبرين هي حل للتشققات أصلاً. يعني في طبقات كثير مشابهة. ما يميز الطبقة الماصة للإجهادات اللي هي الممبرين أنها غنية بالربر من مخلفات الإطارات التالفة، وأيضا الفايبر جلاس، ويعني مصممة بطريقة فنية تساعد على الحد أو تأخير انعكاس التشققات.
واضح. شكرا مهندس. And we will be going back to Engineer Simon for the next question. What's the latest technology used to monitor the road's conditions?
Well, but the answer is simple. I think laser. Laser is where we are now. It's gone from people's eyes to photographs to digital images, and laser is picking up everything. And the lasers are improving seems like every month. They're not, but that is where we are. The writing quality is done by that. The red depth, all the measurements from an NSV are done by that. The deflections under the TSD are done by lasers, Doppler lasers. So that is where we are now. And yeah, it's a huge improvement on people's eyeballs, that is for sure. And again, going back to let's work with fact as opposed to opinion. And I think every one of my learner colleagues here, that excellent presentations have pointed out data, 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 data. True. That is the key. And the more of it you get, the better informed your decisions are going forward. And,
True. Maybe Dr. Allen would like to add more?
Yeah, well, I believe that if you put it all in one, this is the key. If you integrate all these equipment, for example, the texture depth, which is the macro texture, the roughness, rutting, and also the video with for the cracking, and the GPR, which is including the short wave and long wave between 14 to 1800 megahertz, and all that, including the deflectograph, that will give you the complete picture. So if you integrated all that, that is the latest technology that we wish to see it hopefully here in the kingdom, given that the spectrum of the traffic here, and I was traveling from the airport to Kubar, and I could see the tail to nose of all these tracks. There's no way that we're going to use the conventional equipment. We need to use the high speed, and this is the way forward associated with the, as I mentioned earlier, with the perpetual pavement. You need to lift the technology that you construct, and you need to lift the method that you are doing your testing as well. Thank you.
Thank you, Doctor. Yes, go ahead, engineer.
So, am I on?
Yes.
Alan, thank you for that. So in other words, we need to import about 100 iPads here. But yeah, you are correct. Integrating this whole thing has taken a long time, and that is the key. You can see everything in one snapshot there.
Okay, thank you, Engineer Simon. We go back to Dr. Lee. We have a question from Bahrain. So they're saying that they tried the recycling and paving asphalt machine in Bahrain in 3 projects. 2 were failed, and the readability only with the surface was rough. Do you have any idea what's the reason for that?
One of the surface what?
Rough.
Rough.
The surface was rough.
Okay.
Yeah.
The hot in-place recycling application has been defined in terms of distress. What distress should be used, can be treated, can be managed by using the hot in-place recycling. Not every structures, and this partially answer, I think, your question. When you answer that question, I want to add something there. For example, the recyclables maximum 90%. The other 10% cannot be recyclable. I think that when you answer the questions, should include in the what's called, for example, the cracking sealants. Those cannot be recycled. Also, some problems that should be taken out. The fabric, the plastic, something has to be taken out before doing the recycling. So that's one thing. And the other thing is, now we answer the question, the later question. It's structurally should be strong enough. Okay, the hot in-place recycling doesn't fix the structural problems. That's the reason that you can fix only like go up to 50 millimeters deep. Okay, for the recycling. It's a surface. It's a ravening problem. Okay, it's not for cracking. Especially like the structure-related reflective cracking cannot be healed. It will come up within a very short period of time. 1 year, 2 years, it means just failure. So that's some examples. And there's a very clear definition of the application in what kind of a situation, what's the, what problems can be resolved, what problem cannot be resolved.
Thank you, Doctor. ننتقل إلى الدكتور إياد. بخصوص الأسفلت الذكي يوجد سؤال: هل تكلفته في المناطق المتسعة جغرافيا مثل المملكة يمثل تكلفة كبيرة جدا مقارنة بسبل الصيانة العادية؟ وسؤال آخر بخصوص المحافظة على البيئة وإعادة التدوير واستخدام درجات حرارة منخفضة، بالرغم من أن المواد البلاستيكية تحتاج درجات حرارة عالية جدا للاندماج مع الخيط الأسفلتي، وفي حال انخفاض درجة الحرارة هل ينعكس على تماسك الخلطة؟ وكيف يتم الجمع بين الأمرين؟
على السؤال الأول كنت أنا جالس جنب دكتور الحربي، يعني كنا نتكلم عن موضوع السمارت pavements. It's not a solution for every section, of course. It is for probably, if you want to start with an idea like that of collecting data from sensors, I will go to very critical sections, important for that region. To collect data, and from that, with data analytics, you can infer, you can project what could be happening around that area. So it's not, of course, it would be an expensive solution or expensive proposal to do it everywhere in all sections. So it's high priority sections. On the second one, on the plastics, like any technology, when we say a plastic modified bitumen, it's actually many technologies like that. Some of them work, some of them don't work. So you must verify it before you go into the field. There are the ones I spoke about specifically, it's a patent technology we patented. And the idea is how to stabilize, the key word is stabilize the plastics in the asphalt because they tend to separate, especially the polyethylene. So there are technologies, chemical, physical modifications in order to minimize or eliminate that separation. So yes, it's not a solution for everywhere. On it's specific technology that you need to test that it works and meet the specifications. On the cooling and temperature, no, once you mix it, when it cools, there's no separation. But it does work for hot climates. It's not intended for cold climates. That's why I'm talking about it in certain areas where our region, where they're high climate. It's not something that I would recommend in cold climates.
Thank you. I think Dr. Allen would like to add more.
Yeah, there are actually a number of studies around the world. They call it long-term pavement performance sites. For example, in the States, they spend over 150 million. They develop throughout the country. And in New Zealand, we have also the long-term pavement performance site. And what does that mean? That means monitoring site is being established across the country, and they have different performance for each region or each area. For example, in the kingdom here you have 13 regions, and it will be very good to establish this long-term pavement performance site. And this study will be set up at the national level to monitor all what's being built and what will be the suitable for each region, and if there is a good practice need to be shared across the area. For example, the area in the eastern, which is the Dammam, and this is, I would say, an area with the high water table, with the low CBR, and with so many technical and drainage issues as well. It's unlike the one which is in the southern part of the kingdom, whether Asir, Najran, Jazan, or even in Mecca and Medina have different. So with doing the long-term pavement performance site, or they call it LTPP, these will resolve a lot of problem, and it will provide the kingdom with a bank of knowledge and data for future generation as well. Thank you.
Thank you, Dr. Allen. I think Engineer Simon would like to add something.
Just quickly, Alan, we've got a test section. Sorry, I've got a trial section in Durban in South Africa using milk cartons. I think we ground up, so waste plastic about 5%, and we monitored that for about 2 years. I wanted to do it for longer than that, but we didn't. Using iPave and using various other equipment, and we monitored it every 3 months, I think, including traffic. I'm more than happy to give you those results for your database.
Thank you.
Pleasure.
Thank you everyone. طبعا لضيق الوقت يوجد الكثير من الأسئلة، لكن الوقت لن يسعفنا في إجابة جميع الأسئلة. أود أن أدعوكم لتناول وجبة الغداء مع المتحدثين. Thank you everyone, our beloved speakers, for the enriched stage program. I'd like to invite you to have lunch with the participants, and if you'd like to ask any questions during the lunch, feel free to network with the speakers. Thank you, and I'd like to add that في تمام الساعة 6 سينطلق باص إلى 6:30 سينطلق باص إلى إثراء، فاللي وده يحضر الرحلة يكون متواجد في اللوبي. And yes, for the speakers, at 6:30 p.m. There will be a shuttle for ITHRA, King Abdulaziz Center for World Culture, for an enriching cultural experience there. The bus will be waiting for you at the lobby. Okay? Thank you. Thank you, everyone.